I have a ship of length capital L and breadth B, a box-shaped vessel. It is floating at this waterline WL at a draft of D. Okay. Let us say it has an empty compartment. Let's keep it midship to keep it simple. And the length of the compartment is L and breadth of the compartment is B. Okay, the compartment is empty. Now in this condition, when the vessel is floating, what is supporting the ship's weight, beta? What is supporting the ship's weight?
Buoyancy.
Buoyancy.
Water. Very good. And what is buoyancy? How do you define buoyancy? What is buoyancy?
Total weight of body
Is what
acting upward.
Okay.
The displacement.
Force acting upward, which is equal to the
The
weight.
underwater volume that is being
Okay. So we are getting different answers. The first one who was saying little hesitantly was what I actually wanted you to say, that it is the weight of the water displaced. Correct, beta? Correct? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now, and so basically the buoyancy is equal to weight of water displaced. Correct. Very good. What is the weight of the water displaced equal to? That will be equal to volume of water displaced multiplied by density of the water, right guys? Agreed?
Yes, sir.
Okay. In this case, what do you think is the volume of the water displaced? In the case that I have drawn, what is the volume of the water displaced, guys?
L into D.
Very good. That means whatever is the displacement of the ship, that is supported fully by buoyancy, which is equal to L into B into small d, that is the underwater volume, multiplied by the density of the water. And this becomes the displacement of the ship and also is the buoyancy of the vessel. Correct, guys? Correct?
Yes, sir.
Yes, sir.
Okay, now let us say the vessel experiences, so there is an equilibrium. Please remember there is an equilibrium between weight and buoyancy. Otherwise, the vessel would not be in equilibrium. Now, suppose the vessel experiences in breach of hull in the way of this particular compartment. I'm sure all of you would agree that if the compartment was empty because of the head of the water outside, this compartment will be filled with water. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now, this occurrence of water finding way into the ship's compartment can be looked in two different ways. One way of looking at it is as if you have loaded the water into that compartment. And if I treat this water as the water loaded in the compartment, so what happens when I load a weight on the ship? The vessel's weight becomes more. More than what? More than the buoyancy which I have now with the blue box, I have encircled the buoyancy. Now the weight will become more than this buoyancy, yes or no? Correct, beta?
Yes, sir. Correct.
So there will be a resultant downward force which will cause the vessel to sink. As the vessel sinks, underwater volume will increase. That will lead to increased buoyancy. And this will continue happening till there is a resultant downward force. And at some draft, some new water line, W1, L1, the water will keep rising in the compartment, of course, as the vessel sinks. And now, at this stage, at a new draft D1, the buoyancy of the ship, because here what had happened was you said displacement is W1. So this displacement became W1, whereas W1 became greater than W. This led to the sinkage of the vessel, and Now the vessel strikes a new equilibrium at a draft of D1 when the buoyancy again becomes equal to W1. That means you have new buoyancy B1, which equals to W1. Again, the condition of law of flotation is satisfied, and now the vessel attains new equilibrium condition in this particular stage. Do you agree with me? Yes or no, guys?
Yes, sir.
Yes, sir, I think so.
Okay. Now, those who believe, now what triggered the change? What triggered the change under this belief, under this thought process? What triggered the change under this thought process is the addition of the weight. Because you are assuming that the water which has come into the ship is as if it is the weight added on board the vessel. Do you agree with me? So what was the trigger? What was the trigger to the change? The trigger to the change was putting ingress of water, which was loading, like as if you have loaded water onto the ship. And so therefore, everything started because of certain change in displacement. So the trigger was change in displacement. When you consider this water under this school of thought, which I've just described, that is called as added weight method. Okay. If you consider the water that has found its way into the ship's hull because of damage, you treat that as the weight added on board, and then this method of dealing with the damage stability is called as added weight method, as if the water that has gone into the ship is the weight loaded, and then you know from right from pre-C you have been doing what happens when you load a weight on the ship. When you load a weight on the ship, the displacement increases. This leads to change in draft, and this leads to change in all hydrostatic particulars. Yes or no, guys? Correct?
Yes, sir.
Yes, sir.
Yes, sir.
Whether it is
Yes, sir.
TPC, it is MCTC, it is LCB, it is KB, it is LCF, it is KMT, it is KML, whichever hydrostatic particular you may talk about, this will lead to change in all hydrostatic particulars the way you have been doing. That if you have a ship and you load 2000 tons, what happens then? Same thing happens here. Depending on where the loading is done, the kg may change, LCG may change, or the G with respect to central line may change depending on where the weight has been loaded. And what is the weight here loaded? Weight is the weight of the water. So if a forward compartment gets bilged, you know what will happen if you load in the forward part. If a after compartment gets bilged, you know what will happen if you load in the after part. If you if a starboard compartment gets bilged, you know what will happen if you load on the starboard side of the center line of the vessel. So you all are familiar with what happens when the weights are loaded at different locations along the vessel's length and along the vessel's breadth. So basically, under the added weight method, it is the change in displacement which triggers the change in draft, leading to a change in all hydrostatic particulars. This also can lead to change in location of center of gravity of the vessel. That means in terms of kg, in terms of LCG, or in terms of location with respect to center line, all or one or some of them can change depending on where the bilging has taken place. Then, now in this case, FSC will always change. Why FSC would change? FSC would change because one, this compartment may have a creation of a free surface. If like in a hold, if it is bilged and the water is up to this level, then that's a free surface created. That means FSM may be created additionally. Secondly, if the FSM is not created, suppose it was contained, a DB had bilged and it got completely filled in, then you'll say now the DB is full. Where is the creation of the FSM? In that case, even if the FSM remains same, because your FSC is equal to FSM upon W, under added weight method, your W has already changed. So even if the FSM remained unchanged, Do you agree with me what I have said, beta?
Yes, sir.
So can you
Any,
repeat one? Sorry.
what do you want? What do you want me to repeat? Tell me. Up to
Understood.
which point? Which added weight method is here? Okay. So have you understood the added weight method? Yes or no, guys? If any doubts, let me know. What all would change? Why would it
Sir,
change?
sir, I have one question.
Understood.
Yeah. Tell me. What is the
Sir,
question?
when the water starts filling up in the tank, is there a way
Yeah.
to know what water level it will fill up?
It will fill up to the same level as the draft outside, beta. Water will always equalize, no?
Okay, sir. Thank you.
Whatever is the draft outside after filling up, okay, not the initial draft. You see, it has gone above the D because as the displacement increasing, it will go to the level of D1. Whatever is D1 outside, that will be the sounding inside the compartment, right?
Okay, sir.
Any more questions, guys? So can I presume now that added weight method is well understood, guys? And you can answer any question on added weight method to explain.
Yes, sir.
Sir.
Okay, very good. Very good. So added weight
So
method,
one question, sir.
you tell me.
So now when the compartment is getting built,
Yeah.
so the water will be going inside. So we are going to lose some buoyancy. So we need to gain some buoyancy so as well.
That depends. Na? Wait for a while. If this is the weight added, then where is the question? When you load weight, if you load 1,000 tons of cargo on board, do you lose buoyancy?
No, sir.
So when I'm taking this water as the weight which is come on board, then where is the question of buoyancy, loss of buoyancy? In fact, you have to gain more buoyancy to support more weight. Correct?
Yes, understood.
Correct, Vimitra? So
Yes,
is the added weight method clear to everybody, Vita?
Yes, sir.
Yes, sir.
Okay.
sir.
If you just take screenshot of this one, this is good enough for you to recall everything that I've said. It does not have to be written in ready 2 pages and given to you. Every time it is not necessary that you should go through lengthy notes. Sometimes, and you should be able to put your thoughts in place and write the answer if somebody is asking you added weight method. Okay. Now we come to the second way of looking at the same thing. Okay.
Sir, can you please slide one slide back, please?
Okay. Okay, don't worry about the title. The people get distracted by it. That's why I was doing on that sheet. Anyway, never mind. The same ship which we had there, same ship in the intact condition, and intact condition equilibrium is same. Length L, breadth B, floating at a draft of D, at a waterline WL. There is a midship compartment, small l, small b, and empty. And again now, there is a breach of hull in the way of this compartment. Okay, now before that, in the intact condition, we all know it's gone. Diagram is gone, is it? Oh shit. No, wait, it's okay. Let me try it again. Okay, here is the box-shaped vessel. Length capital L, breadth capital B, floating at a draft of D at waterline WL. There is a compartment midship which is empty of length L, breadth capital B. As we have just discussed a while back, the displacement of the ship will be equal to buoyancy, and the buoyancy in this case again would be the same, LBD into the density of the water. Yes or no?
Yes, sir.
In this beta, this volume is called as, if you remember in BMT and BML, we had V in the denominator. So this is the volume of buoyancy or volume of displacement, whatever you want to call it. Agreed? LBD is the volume of buoyancy or volume of displacement. Why? Because this is the volume whose weight is equal to the buoyancy. Yes or no? Correct, beta?
जी sir.
Okay. Now this compartment gets bilged. And obviously what will happen? Same thing will happen. The water has to get into the compartment. Nothing is going to change as far as that particular part is concerned. So it gets bilged and water gets into the compartment. As the water gets into the compartment, the other school of thought is that what happens? This water is not in your control. When I'm saying not in your control means it can come in at its own will and it can go out at its own will. Guys, what will happen if there is a bilging that has taken place? Now, suppose this ship rolls or ship pitches. When the draft midship will reduce, the level of the water inside the compartment will reduce. When the vessel dips down in the midship region or there is a crest here, the water outside will rise and the water in this compartment will also rise. So that means the water will be free to go in and come out. Yes or no? Correct, beta?
Yes, sir.
Do you have control over this water?
No, sir.
No, no. So the
No,
other
sir.
school of naval architects feels that this water which has gone into the compartment over which you have no control, it does not belong to me. It belongs to sea. Why? Because it is freely communicating with the sea. It's going in, coming out at its own way. It's part of the sea. That means the volume that is occupied by this water, which is freely communicating with the sea, that volume has now become part of the sea and does not remain my volume anymore. Correct? Now, when that volume does not, so earlier you see, beta, the volume that I am now enclosing with the green box, this volume was contributing. I had three volumes, volume V1, volume V2, and volume V3. My volume of buoyancy before bilging was V1 plus V2 plus V3. All of you agree before bilging this was the volume of buoyancy? Yes or no?
Yes, sir.
Now what has happened is if I treat this volume occupied by the sea water to be not belonging to the ship, that means it does not contribute to buoyancy. If it does not contribute to buoyancy, so now if the vessel remains afloat at WL and does not change, there is no change in draft, then the buoyancy, if V3 is gone from my pocket, then what am I left with? I'm left with only V1 and V2, correct? That is providing buoyancy now. Yes or no, beta?
Yes, sir.
Yes or
Yes, sir.
now?
Yes, understood, bro.
Yeah,
Yes.
we have not loaded any weight on the ship. We have not discharged any weight on the ship. The displacement of the ship is still W. So when I multiply V1 plus V2 with the density of the water, then my buoyancy is going to fall short of displacement. Yes or no?
Yes, sir.
Why? Because displacement was equal to V1 plus V2 plus V3 into density. Now V3 is no more there. So now the buoyancy, which is V1 plus V2, the weight of the volume 1 and plus weight of the volume 2 is going to be less than displacement of my ship. Does everybody agree on this point? Yes or no?
Yes, sir.
So if the buoyancy provided up to waterline WL falls short of the displacement, which has not changed, because if the seawater, the water in the compartment does not belong to me, then it does not add to my displacement. What will add to my displacement? What belongs to me? If something does not belong to me, it does not add to my displacement. So now what has happened is in this school of thought, if the vessel continues to float at draft D at waterline WL, the displacement of the vessel is W. It falls short of displacement because there is a loss of certain volume which was earlier contributing to buoyancy. Do you all agree on this, that what I've said, or any questions, guys? Clear up to this point? What will be the resultant force? The resultant force will be downwards. Why? Because W is greater than the weight of buoyancy provided by V1 and V2. This will cause the vessel to sink. Now the vessel will sink and more buoyancy is getting added. And when the new buoyancy again becomes equal to W, that means water will rise at this up to this point. Now, when the buoyancy becomes equal to W again, a new equilibrium will be reached at draft D1. This draft D1 is going to be same as the draft in the earlier case D1. But in the first case, in the added weight method, I use this expression and I would like you to repeat. What was the trigger to change in added weight method? What was the trigger, guys? Trigger was the addition or change in the displacement. What is the trigger here? It is the change in the buoyancy. Change in buoyancy. The buoyancy falling short. The outcome is same. In both cases, the vessel is sunk. She sinks to the same draft, whether under added weight method or this particular method which we are yet to name. But in both cases, the trigger is different. In one, the trigger was increase of displacement. In the second, the trigger is falling short or buoyancy falling short because you have lost some of your buoyancy. In the second case, which is on display, the trigger is because of buoyancy lost, and the change is taking place because you want to regain the lost buoyancy. You want to regain the lost buoyancy. In the earlier case, the trigger was increase in displacement, and the sinkage was taking place because you wanted to increase the buoyancy to match the displacement. Here, the trigger is loss of buoyancy, and the desired effect is to regain the lost buoyancy. Do you agree with me, guys? Have you understood?
Yes, sir.
Yes, sir.
Those who follow this method of Bilging, this method is called as lost buoyancy method. These are two different methods. So don't bring lost buoyancy when I was talking of added weight. That's a different way of handling the problem. This is a different way of handling the same problem, right? Now, in the lost buoyancy method, what has happened? Draft has increased. Yes. But the reason for the change is different. Okay, why it has changed? Because buoyancy has been lost and you need to regain the lost buoyancy. What does not change is the displacement. Correct, guys? Because this water which has come into the hull does not belong to me. Okay, understood? Okay, now if the draft has changed, some of the particulars all the particulars other than displacement is not changing, though the draft has changed, but other particulars will undergo a change. Height particulars which are dependent on draft will obviously undergo a change because like buoyancy is the geometric center of volume of buoyancy. Buoyancy distribution has changed. So LCB will change, KB can change. LCF is a geometric center of the water plane area that can undergo a change. What does not change is the displacement. And if displacement does not change, what is also very significant is what does not change is the center of gravity location. That means Kg remains unchanged, LCG remains unchanged, and COG with respect to center line remain unchanged. These are very distinct advantages of this method. Otherwise, there is no superiority or inferiority between the two methods. And another big advantage is FSC does not change. Why it does not change? Under normal circumstances, I'm not going to very specific cases. Why? Because FSC you said is FSM upon W. One is if displacement has not changed. So if FSM has not changed, fine. Secondly, in this compartment, if the free surface is created, that's the free surface in the compartment, and that liquid does not belong to me, then how can its free surface belong to me? You see, the free surface correction will be applicable only to the free surface of the liquids which belong to me. This liquid under lost buoyancy method does not belong to me, it belongs to sea. It is like the sea surface outside. If the sea surface outside does not bother me about the free surface effect to my ship, why should part of this sea inside my ship bother me? So even if there is a free surface created in the compartment, the free surface does not become the ship's free surface, and therefore it does not add to the FSM. Therefore,
Excuse me,
yeah, tell me.
sir. After coming to
There is no technical superiority in the results obtained from added weight method vis-a-vis lost buoyancy method. Both are more or less the same, good or bad, whatever you want to call them. But lost buoyancy method, because of these inherent things, one, displacement does not change, which does not cause a shift of center of gravity. And the free surface does not count to the free surface of the vessel. These are the advantages of lost buoyancy method, which make it easier to use. Okay, so we usually resort to lost buoyancy method, not because of its technical superiority. We resort to lost buoyancy method because of the convenience, because it is easier to apply. Is that clear, beta?
Yes, sir.
Okay, so if
Sir, sir, I have
about calculations under lost buoyancy method, let's stick to that. We will not keep bringing up the added weight method time and again here. Okay, so here is the same ship, guys. Length L, breadth B, floating at a waterline W. Now these will be the standard notations we'll use in our working, and if you standardize your notations, you will see, because expressions will become very lengthy as we keep moving forward. So notations have to be standardized. So we will every time represent our ship's length by capital L, ship's breadth by capital B, her is WL, her draft in the intact condition is D, then the compartment, its length will represent by L, its breadth will represent by small b, small l and small b. And after the bilging takes place, the vessel will go to a new water line where it will settle. That water line will mark always W1, L1, and the draft we are D1. These will be our standard notations that we'll use. Is that clear, beta?
Yes, sir.
I'll be using, I'll keep highlighting them. And B, take a pause before you respond, but try to respond, because if you respond correctly, it adds to your confidence. You respond wrong, you get corrected. You remain quiet, you will never know whether you wanted to respond correctly or you were wrong. Okay. Now, the vessel has sunk from WL to W1L1 because of what? Because of lost buoyancy. Look at this
Lost
diagram, guys.
buoyancy.
Yeah, look at this diagram and tell me, look at this diagram and tell me, because of bilging in the notational form, what is the lost buoyancy?
L into B into D, sir.
L into B,
Small L into small b,
small l into small
small
b
L
into
into
small.
small b into small d.
Guys, this is the
Example.
lost. This is the lost buoyancy. Yes or no? This was the buoyancy which was. This was the buoyancy. This was the buoyancy which was earlier contributing the total buoyancy. Again, just for explanation, we'll not use it time and again. Let's say V1, V2, and V3. These were the three volumes of buoyancy that were contributing to the buoyancy in the intact condition, right? So when you say lost buoyancy means lost money is the money you had and you lose from there, not something which you have to receive later. So in this case also, what was the buoyancy that what was the buoyancy you had in the intact condition? Now, if I draw a box here in red, do you agree this was the buoyancy I had in the intact condition, guys?
Yes, sir.
Yes, sir.
Out of this, I'm sure now you will all agree, lost buoyancy is then small l into small b into d. It is not d1. You see, water rises here, never mind. But this part where the water has come, it was earlier not contributing to buoyancy. It was above the water line WL, correct? Correct, guys? So does everybody agree that lost buoyancy is LBD? If anybody has any questions, after that we should not come back to say why lost buoyancy has not been taken up to W1, L1. Why not up to D1? If anybody has any questions, let's settle them here. Does everybody accept that lost buoyancy is LBD?
Yes, sir.
Yes, sir.
Very good, fantastic. Okay. Now, you see, where are the buoyancies regained? What was the volume which was above the water line before bilging? And what is the volume that has gone below the water line after bilging? Now, this is one volume that was above the water line before bilging and has now gone below the water. This is another volume which was above the water line before bilging and has gone below the water. This was another volume which was above the water line, has gone below the water line or now. These are the three volumes A, B, and C. These are the three volumes which were earlier above the water line WL, but after bilging they have gone below the water line W1, L1. Do you all agree?
Yes, sir.
Yes, sir.
Yes.
So one minute. A, B, C.
Yeah. Small a, small b, small c.
Yes, sir. One minute. Let
Three. Guys, like V3, which is now lost, C is going to join hands with V3, yes or no?
Yes, sir.
Right, sir.
C is going to become part of V3, yes or no? So
Yes,
therefore,
Yes.
C in the bilged condition, is it going to contribute to regained buoyancy, yes or no?
No, sir.
no.
C will not contribute to regained buoyancy. Does everybody agree with that point of view?
Yes.
Yes, sir.
Because C is part of the water which is freely communicating with the sea, right?
Yes, yes, sir.
Yes, sir.
C is part of V3 now.
Right.
C has joined V3, so it has become V3 plus C now, right?
Yes, sir.
Correct. But A and B volumes, they will add to the buoyancy, yes or no?
Right, sir.
Yes, sir. Yes.
Out of A, B, C, the buoyancy regained would be only A and B. Does everybody agree with
A
me?
and B.
C is not, C
Yes,
has
yes.
gone underwater, but it's not contributing to buoyancy. Am I clear, guys?
Yes, sir.
Correct.
So
Now,
just
A, yeah,
it is A and B or A plus B.
A and B are A and B means what? A plus B only, no?
Okay, okay. So,
I didn't say A or B. Now you tell me, guys, if A is a volume, B is a volume, then do you agree with me? Then do you agree with me that buoyancy regained will be equal to A plus volume B? Yes or no?
Yes,
Yes,
yes.
sir.
And do you also agree how much will I regain? I have to satisfy law of flotation. I have to regain only as much as I lost. Yes or no?
Yes, sir.
Yes, sir.
My lost buoyancy cannot exceed the my regained buoyancy cannot be exceeding the lost buoyancy. So my regained buoyancy has to be always same as lost buoyancy. Yes or no?
Yes, sir.
All aligned up to this point?
Yes, sir.
Okay. Now, beta, listen to me now. Now, how do we calculate A and B? How do we calculate this A and B, the regained buoyancy? There can be different ways. You calculate this volume A, calculate volume B, and add them. But that is not a user-friendly way. Okay. How we will calculate is, for that I will basically introduce few terms. Okay. Now, suppose I draw the water plane area in the bilged condition. I draw the water plane area in the bilged condition at W1 L1. That means you imagine the vessel to be cut at W1 L1, have a bird's eye view. And when you'll have a bird's eye view, first tell me what will be the shape of the water plane area. Only the shape you tell me first.
Rectangle.
Rectangle.
Rectangle, sir.
Rectangle.
Two
Very good.
rectangles.
This will be the water plane. When
We,
you will
we
see from top, you will see these two bulkheads like this. Yes or no in the plan view? Correct?
yes, sir.
And what will you see? Here you will see the sea water which is freely committing. Correct? Why?
Yes.
Because you're
Yes, sir.
the sea water. Yes or no?
That is the
And this sea water is part of the sea. Yes or no?
Yes, sir.
Correct? So
Yes,
that
sir.
means this sea water which I have shaded is part of the sea. Then this area also does not belong to or also does not belong to me. Correct, beta?
Yes, sir.
Okay. Now let's. So this is small l and this is small b. In this case, I'm assuming small b is same as capital B. This can be less or more, whatever it is. Now there are three distinct terms. One is whole water plane
So,
area.
sorry to interrupt you, sir. So
Yeah.
this small b will be always equal to capital B, na, sir?
Oh, that will be given. In this case, I have taken equal, but it can be different.
How different, sir?
The compartment may not extend from side to side, no?
Ah, okay, 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 sir.
Okay. Guys, one term we'll be using will be the whole water plane area. Whole means whole. Look at this diagram, this one. What is the whole water plane area? L. Understood? Have you understood the meaning of whole water plane area, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Other we'll be using would be lost water plane. And when I say lost water plane, I mean lost water plane area. It is implied. In this case, what do I mean by the lost water plane area? I mean the water plane area of the ship, which is not actually ship's water plane area, which is lost because of bilging. And I'm sure in this case you'll agree, small l into small b, the lost water plane area. Correct, guys?
Yes, sir.
Correct.
Okay. The third term we'll be using would be intact water plane. Now, in this case, what is the way we can get the intact water plane? One way of getting the intact water plane is you calculate this green area and calculate this green area and add them up. Correct, beta?
Yes, sir.
This is
Yes.
correct. The other way of getting the same thing is from the whole water plane. Yeah, from the whole water
minus
plane area, you remove the lost one. Correct. So intact water plane area, what we will be using, because that will be simpler in all cases, whole water plane minus lost water plane. So have you understood the meaning of intact water plane? A1 and A2, they together form the intact water plane. This blue one is the lost water plane. Correct, guys? This is intact and this is intact. Am I clear about these three terms? Whole water plane area, lost water plane area, and the intact water plane area. Correct, beta?
Yes, sir.
Agreed, guys? All these three terms. Please have your doubts raised at every step wherever when we are covering, because we will keep climbing one step at a time. So whichever step you feel tired or you have a problem in understanding, please raise it then, so that the next step is easier to climb. You are adequately about the base, you have a strong base, and then you can keep going up. Okay. Okay, these three terms will be using in our sessions: whole water plane, lost water plane, intact water plane. Now look at this diagram here, guys. Is the water plane in the bilged condition? Now pay attention to my statement. Is the water plane in the bilged condition same from WL to W1L1? That means if I cut the ship at WL in the bilged condition, is the water plane going to be like this? If I cut it somewhere between WL and W1L1, is it going to be same? At W1L1, is it same? Tell me yes or no.
Yes.
Yes, sir.
Yes, sir.
You
Because
have,
bird's eye view. Consider.
but yeah, at every level, the bird's eye view will be same. You will have the whole, and this middle part will be lost in every case, right?
Yes, sir.
Correct. So, what
Yes,
is
sir.
volume? What is volume? Volume is a in a box-shaped vessel. It is area of the base multiplied by height. Yes or no? Correct, beta?
Correct, sir.
Yes, sir.
See, if I was to calculate volume A here, one way only A. I'm not talking of B and C. Then what will you do? Area A1, which is here, your green wall, multiplied by sinkage will be volume A. Yes or no?
Yes, sir. Yes, sir.
Guys, volume A, let me use the red marker to highlight again, draw your attention. Some of you may be lagging behind on it. I'm talking of this volume A, guys, this volume A. Is it equal to area A1 multiplied by sinkage? Yes or no?
Yes, sir.
Yes, sir.
Correct? Correct?
Yes,
Likewise,
sir.
Correct.
is volume small b, this one, equal to A2 multiplied by sinkage? Yes or no? This distance is sinkage. This is sinkage, right?
Yes, sir.
Okay. That is one way of getting the regained buoyancy, A plus B. Other way of getting the regained buoyancy straight can be intact water plane multiplied by sinkage, because intact water plane is what? A1 plus A2?
Yes, sir.
Correct,
Yes, sir.
beta? Correct? So do you agree with me after all this discussion that lost buoyancy, you have already agreed with me? I'll not rake up that issue again. Small l into small b into d. Now, please look at it and tell me if regained buoyancy is equal to intact water plane into sinkage. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Guys, anybody has any questions here? Intact water plane into sinkage. Yes or no?
Yes, sir.
Yes, sir.
Okay. And since both these have to be equal, lost buoyancy has to be equal to the regained buoyancy, then what do we have? We have intact buoyancy, intact water plane into sinkage, which is your regained buoyancy. It should be equal to lost buoyancy by law of flotation. And this gives us the formula for finding sinkage, gentlemen. Sinkage will be always equal to lost buoyancy divided by intact water plane. This becomes the formula for my sinkage. Please review it because this will be the first step of every question in Bilging. Finding sinkage will be the very first step everywhere when you deal with the lost buoyancy, because the first thing you want to know is what is your new draft. How we will calculate them, we'll see them when we take questions. But fundamentally, sinkage is lost buoyancy divided by intact water plane. Clear, guys?
Clear, sir.
Clear, sir.
Okay, I give you what's the time now? 10:35. I give you 5 minutes to review that has been said. It's not that I know you're not tired, but I still want to now 4 minutes. It's 10:36. 10:40 till 10:40. I'm very much online to hear. It's not a break. It's I'm giving you 3-4 minutes to absorb this entire thing. And if you have, I will do the way, and I'll keep explaining to you. If you have any problems with the explanation, you can interject anytime. You can interject anytime. You don't have to wait for the question to get over to ask your doubts, because it is always easier to address them on the run. So shall we start, guys? All ready? Kar de shuru? Okay.
sir.
Okay. I will tell you and if you follow what I'm telling you, you will not have many problems. One is use the notations, what we just learned. A box-shaped vessel, 100 meter long, 20 meter wide, kg 7.5 meter, is floating at an even keel draft of 6 meters. It has an empty midship compartment of length 30 meters, breadth 20 meters. Calculate the GM of the vessel in the intact condition and after the compartment is bilged. First thing is, you will always make a diagram in the side elevation. What do I mean by that diagram, guys? And without diagram, you'll never be able to do the questions. This is my ship. Length of the ship, though the value is given, but I'll always represent with capital L, 100 meters. Why? Because I'll be using a lot of notational this thing. Breadth is 20 meters, capital B. It is floating at an even keel draft of 6 meters. This water line will mark as WL. This is small d, which is 6 meters. It has a midship empty compartment. Length of the compartment is 30 meters. Breadth of the compartment is 20 meters, represented by small l and small b. Now it's a box-shaped vessel, guys. Kg of the ship is given as 7.5 meters. Can you find out the GM in the intact condition? We have already dealt with this in our MOI, guys. Can you calculate, please? Yesterday, we had a lot of GM calculations involved with the different shapes. We calculated the GM, all constituents of KM also we calculated. So can you please calculate the GM in the intact condition? That has nothing to do with the bilging. That is part of what we did over the last 2 days.
Yes.
Yeah, how much? If I give you this question here and say find the GM, forget about bilging.
Yes, sir. We will calculate the.
Calculate. No, we will not calculate. Please calculate. Please calculate. We will not calculate. You calculate it.
Sir, 1.055.
1.05.
Okay, 1.055. Okay,
1.055.
very good. Anybody who doesn't know, if all of you know, then I'll not waste time.
1.05.
0.5?
1.055, sir. KB plus BM minus kg.
Yeah, very good. Okay, I've not put the answer here. Okay, never mind. If everybody's got the same answer, then I'll not waste time on part A.
Yes,
It has
sir.
nothing, yeah, it has nothing to do with Bilging. So I'll go to part B straight. Is there anybody still solving part A? Please let me know. I can wait for you before I
Yes,
go.
sir. Yes, sir. Yes, sir.
Yes, sir. 1 minute. 1 minute.
Yeah, please solve
Yes,
it and let me
solving.
know. Yeah, solve it. Let me know once done. Let's not create confusion. Do it and let me know. Guys, if I have to save time, I can always solve and run away with the solutions and say it's done. I don't want that to happen. If it takes time, it's okay. I'm not in a hurry. The easiest thing for any tutorial is to just keep solving on the board and you will be more than happy to copy. That will not help you. Please solve it. 1.055 people are saying. If so many of you are saying, it must be correct then.
Yes, sir. 1.05.
Very good. Anybody else who's still solving? Yeah, very good. Very good.
1.05.
0.55 is what people are saying.
Okay, sir.
Let,
1.05.
let me see if I have solved. Let me
I
just.
got 2 point something. I don't know. I may be wrong somewhere.
No, then you must be wrong. Side elevation, I will shade the lost buoyancy. Please, and I'm sure all of you would agree what I have shaded represents the lost buoyancy. Correct, guys?
So I
Yes,
missed
sir.
out. So the shaded area is the lost buoyancy, correct? Okay.
Shaded area cannot be lost buoyancy. Buoyancy is volume. This is side elevation. This is volume that I'm trying to represent, not the area. So don't make these technical mistakes, man. You're saying shaded area is the buoyancy. How can area be buoyancy? Okay. This will cause the vessel to sink to a new water line, and we have agreed will represent it by W1 L1. And what happens? The water will rise here, but I am not crossing it. Why? Because that is not adding to the lost buoyancy. Lost buoyancy will remain what I shaded. But when I show water here like this will remind me that it is not, the buoyancy is not regained in this part. Okay. Now this is what I have drawn, and this becomes my D1. Having drawn the side elevation, right below it, you will draw the water plane at W1 L1 in the bilged condition. The water plane at W1 L1 in the bilged condition, and you don't have to explain, you will just keep drawing like this. The overall length of the water plane will be 100. Overall breadth of the water plane will be 20 meters. You will see these bulkheads right below these ones, so you can draw under it. The length between these bulkheads will be 30 meters. Breadth of this compartment, small b, is 20 meters. And this will be the lost water plane in the bilged condition. Guys, do you agree with these two diagrams? Yes or no? Upper is the side elevation. Down below, this is the water plane.
Yes, sir.
Any questions on the diagrams? Please let me know if
No,
there is
sir.
any doubt. Okay. These are the diagrams which hold the key to your every question, beta. So these two diagrams are essential, imperative. Okay. Now, the first step will be to get the sinkage. We just learned that sinkage is equal to, you want to write, you write, otherwise you can just recall and talk to yourself. Lost buoyancy upon intact water plane. Now I'm sure you'll agree that lost buoyancy value in notational form, don't worry about the values, will come from the upper diagram. So the numerator will come from the upper diagram, and I'm sure you'll agree it will be LBD if you look the shaded portion in the upper diagram. Correct, guys?
Yes, sir.
Correct.
Correct. Correct.
The numerator is water plane, so it will come from the lower diagram. Whole water plane is capital L into capital B minus the lost water plane is small l into small b. So I said whole water plane minus lost water plane. Does everybody agree this is the sinkage formula then for this case? Yes or no?
Yes, sir.
Now you
Yes,
just have to put values. Small l is 30, small b is 20, small d is 6, capital L is 100, capital B is 20, small l is 30, small b is 20, and this will give you sinkage and
571.
2.571.
571 meters. Please, everybody to see this step. Only this much is to be written, nothing more than that for sinkage. But you need to be talking to yourself with clarity so that you don't mess it up. Because get the KB and BM in the bilged condition. We add them, we'll get the KM in the bilged condition. So that is what we have to aim at. Okay. Now, in this case, let's first learn to calculate KB. Okay. Now, in this case, I'm telling you upfront, I'll tell you the shortcut later. The KB, so now we are solving for part B, the bilged condition. KB in the final condition, that is bilged condition, in this case will be D1 by 2. Okay. So once I know I can cut short, but we will learn to calculate because if I have any doubt, I should be able to calculate it. And how do
Sir,
we calculate? Yes.
sir, here since the compartment is two whole breadth, that's why we are taking D1 by 2. Otherwise, we have to calculate by that area method, na?
Volume.
Sorry, moment. We have to take the moment, then we have to calculate the KB, correct?
What did I said? Are we going to take D1 by 2? You didn't listen to me thereafter. I said let's calculate it still.
Oh,
I said it will come D1 by 2 and I'll tell you why it is D1 by 2, but let's first learn to calculate. That is what I close the sentence with, right?
Yes, sir.
yes, yes.
So even here, let's calculate it first. Because if I ever have doubt whether it is D1 by 2 or not, I should be able to calculate. Guys, what is B? B is the geometric center of volume of buoyancy. B is the geometric center of volume of buoyancy. Now, I will not mess up the diagram anymore. I will be doing some marking only for explanation. You don't have to do that. You see, in the bilged condition, whatever I'm doing now is going to mess up the diagram, but that should not be the part of working. Don't treat this as part of working. I'm using a very, very light green shade. I'm sure you'll agree that the volume of buoyancy in the bilged condition is one is this volume, this portion volume, and other is this portion volume. Correct, beta? Correct?
Yes, sir.
And geometric center of this one would be here somewhere at this point. Geometric center of this one will be at some point here. So the geometric center will be at this level D1 by 2. Yes or no? Correct, Peter?
Yes, sir.
But we calculate. Let's calculate it. Now you see. How do we get in Simpson's rules? How did you get KB? You divided the moment of volume of buoyancy by volume of buoyancy. Yes or no? Moment of volume by volume. Correct, guys? You remember that?
Yes, sir.
yes, sir.
Okay. So we will calculate the KB by taking moments of the volume of buoyancy about keel because it is from keel. Okay. One way of it could be that you take the moment of volume V1, which I have now marked, and volume V2 and add them. We will not use this. Instead, we will use the moment of the full underwater volume. Now, mark the words full underwater volume. Now, guys, I'll explain only this one, but next time you'll talk to yourself. but use the notation. Do you agree what I'm binding in blue is the underwater volume of the vessel in the bilged condition? Yes or no?
Yes, sir.
Correct? Okay. And out of this underwater volume, do you agree with me? Do you agree with me that this volume, now this much volume is not contributing to buoyancy? Yes or no?
Yes,
Yes,
sir.
sir.
Yes.
Out of the total underwater, so now there are distinct terms. You see, when until now you were saying underwater volume is same as volume of buoyancy. It was okay for the intact ships, but in the bilged condition, underwater volume is different and volume of buoyancy is different. Correct, guys?
Yes, sir.
So do you agree the blue boundary is the underwater volume and the yellow boundary box is the volume which is under the water but not contributing to buoyancy? Am I clear?
Clear, sir.
Yes, sir.
Okay. Today I'm writing it in words, but you don't write. You will only speak to yourself and keep doing. Only for the sake of clarity, I'm saying one way I can get KB final is vertical moment, means moment about keel of underwater volume. That is the full blue volume. From this, if I remove the vertical moment of underwater volume not contributing to buoyancy, what will you be left with? You will be left with vertical moment of volume of buoyancy, yes or no?
Yes,
From
sir.
the
Yes, sir.
vertical moment of the total underwater volume, if I remove what is not my contributing to my buoyancy, I will be left with vertical moment of volume of buoyancy, yes or no?
Yes, sir.
Yes, sir.
And this one
Sir,
divided
we can
by,
call it as intact underwater volume as well, correct, sir?
sorry,
We can call
what
it
do,
as intact underwater volume also.
what do you mean by intact underwater volume?
Uh, the total volume minus removing of loss of
But
buoyancy.
which method are you following? Lost buoyancy. So why not talk in terms of buoyancy?
Yes, sir.
If you are using lost buoyancy method, why you want to
Okay, sir. Okay.
coin your own terms,
ठीक है, sir.
right?
ठीक है. Okay.
Guys, everybody is okay with this formula? This is for you to just talk to yourself. Now, you will help me now now what you will do is this step. KB final. I'm talking to myself now. Vertical moment of underwater volume. So I look at the upper diagram and in the notational form, first thing I'll do is I will identify what is underwater volume. And if you see the blue box, I'm sure all of you would agree that underwater volume will be LBD1 in the bilged condition. Yes or no?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Does everybody agree this is the underwater volume? For moment,
Yes.
you
Yes, sir.
need to multiply by its liver. Liver means distance of the geometric center of this volume from keel. So what will be the vertical liver of this volume?
D1 by
D1 by
Now,
2.
D1 by
even
2.
divide by
This is the first term that I have got here, right, guys? This is that is why I'm saying use the notational form. So KB final will be, this is the vertical moment of underwater volume. LB D1 is the underwater volume. D1 by 2 is its liver. Correct, guys?
Correct, sir.
Minus vertical moment of volume that is under the water but not contributing to buoyancy. First, look at the upper diagram. First, identify the volume which is underwater but not contributing to buoyancy. Tell me in the notational form what will be that volume?
small
Small L
L
into
into
small
small
l
b
into small
into
b into
D1.
d1.
Into
to
D1. Does
D1.
everybody agree?
Agreed,
Correct?
sir.
Yes,
What
sir.
will be its liver from keel, its geometric center? d1 by 2.
D1 by
Same.
2.
D1 by 2.
So this completes the numerator. All these values you know. Next step, I'll put the values and calculate. Divided by volume of buoyancy. Now, guys, one way of getting volume of buoyancy is this. This minus this. Yes, that's the principle of moments. Total underwater volume minus volume that is not contributing to buoyancy. But a simpler, faster way under lost buoyancy method is, has my displacement changed? So one way is LBD1 minus LBD1. This one all of you agree, right? This can be the denominator,
Yes, sir.
right?
Yes,
Yes.
sir.
But we are following lost buoyancy method. Under lost buoyancy method, has the displacement changed?
No, sir.
No,
No,
sir.
sir.
So whatever was the displacement in the intact condition, look at the upper diagram. In the intact condition, what was the volume of buoyancy?
L into B into D.
L into B into D. Does everybody agree with this answer that is given?
Yes, sir.
Yes.
When will volume of buoyancy change? It will change when displacement changes, right? Or the density of the ship changes. Because why? When you load or discharge, there will be rise or sinkage, correct?
Yes, sir.
Or there is a change of density where vessel goes from one density to another, the draft increases or decreases, right? Correct?
Yes.
Yes, sir. Correct.
My question is, volume of buoyancy to change, either the density should change or the displacement should change, correct?
Yes,
Yes,
sir.
sir.
In my case, under lost buoyancy method, there is no change in displacement and the ship is wherever it was floating, right?
Yes, sir.
Right.
So my volume of buoyancy will remain LBD. So I can directly put LBD here. If you calculate this also, this will come same as LBD, beta. Understood? So it is up to you. You can always keep the denominator as LBD, not D1. Am I clear?
Clear, sir.
So now I can put the values. Capital L is 100, capital B is 20, D1 is 8.571, D1 by 2. Don't divide unnecessarily. Let the calculator do it on the run. Write like this and finish it off. Minus 30 into 20 into 8.571 into 8.571 by 2 divided by volume of displacement 100 into 20 into 6. And now I pick up the calculator and I'll get the KB. This will obviously come half of it. This should come 4.228
285.
86 हो जाएगा राउंड ऑफ करके 4.286 राइट
Exactly तो सर 4.28528 आया.
हाँ तो थर्ड में राउंड ऑफ करोगे कितना होगा 6 होगा मुझे नहीं पता 5 होगा 6 होगा
5
अजय 5 में
4.286, sir.
8.571 को 2 से डिवाइड करो भाई कितना आता है मुझे नहीं पता अगर 5 आता तो आई मेक इट 5
286, sir.
यही है सर
5.
286.
राउंड ऑफ करके 286 आएगा सर.
अरे भाई थर्ड डेसिमल प्लेस पे राउंड ऑफ करोगे ना यार
सर कैलकुलेशन से भी इतना ही आ रहा है 4.282 आ रहा है सर
282 तो नहीं आएगा
28507 आ रहा है.
हाँ 285 हाँ वो पता है क्यों आ रहा है बिकॉज ये जो ड्राफ्ट आपका है ना ये हमने यहाँ पे इसको LBD1 माइनस LBD1 को LBD से रिप्लेस कर दिया और थोड़ा बहुत उसके कारण आ रहा है बट दैट्स फाइन दैट्स फेयर नो
थर्ड
इश्यूज
डिजिट में तो आ सकते हैं ना सर.
अरे पर वो एक ही नंबर ऊपर नीचे होगा ना इट कैन नॉट बी somebody is saying something else altogether different
अच्छा.
so what is the KB so guys this is how the KB will be calculated wherever it is required to be calculated you will take the vertical moment of the underwater volume. From there, you will remove the vertical moment of volume that is under the water, but not contributing to buoyancy. And that vertical moment will divide by volume of buoyancy. Is that clear, guys?
Yes, sir.
Clear, sir. Clear.
Sir, so in exam we have to follow the steps which we have done right now, not
No,
even by
no,
two.
no. No, in this case, you'll have, if you are using d1 by 2, you'll have to give the reason. Okay. Now, when will KB be d1 by 2? Please understand that. If you, in the bilged condition, I'm emphasizing on the word bilged condition. If in the bilged condition, from keel to W1 L1, in the bilged condition, from keel to W1 L1, if the water plane is identical like this at all levels, that means you cut at half a meter, you cut at 1 meter, you cut at 2 meters, you cut at 4 meters, you cut 4.5 meters, you cut at WL, you cut at W1L1. If the water plane is like this at all the levels, then KB will be D1 by 2. Understood? Understood, guys? What is the formula for BM we did, guys?
B square upon
B square by 12.
I'm asking you BM formula.
I
I upon V.
I of what? About which axis? Tell me.
Water plane area.
About forward and aft.
Forward and aft.
What? Water plane area. Which water plane? Obviously intact. So now I am quietly inserting a word here. Intact water plane area. Because whatever is not mine, it cannot affect me. About which axis? About fore and aft axis through COF divided by volume of displacement. Okay, guys. Now let me change to blue marker. Look at the lower diagram, which is the water plane at W1L1. Look at this water plane, W1L1. Now, what is center of flotation? It is the geometric center of the water plane area. Now, in this diagram, which are the intact water plane areas? One portion of the intact water plane is here. One portion of the intact water plane is here. Correct? Geometric center of this one would be here. Let me call it as G1. Geometric center of it will be here as G2. Where do you think will be the geometric center of these two water planes together? Where will be the
Middle.
somewhere in the middle, like yesterday when you were doing that circle wala thing? You had those pontoons yesterday. You said center of
Yes, sir.
flotation is right, correct?
Right, sir.
So do you agree center of flotation is here? Not because it is the geometric center of the whole water plane. No, it is the geometric center of intact water plane. This one and this one. Is that clear, beta?
Yes, sir.
Correct?
The same like yesterday.
Yes. But exactly same like yesterday. Now, when I draw a fore and aft axis, does that become center line? Yes or no? Yes. So I'll not write this formula in my working. This was only to recap with you. I'll write like this. PM, I'll write with respect to my diagram. I about CL of intact water plane upon volume of displacement. Do you agree with it?
Yes, sir.
Correct, sir.
Yes, sir.
Now, I have two cases. One is the whole water plane and other is the lost. So if I take the moment of inertia of the whole water plane about center line, and from there I remove, when we had two different shapes in COP, triangle and rectangle, we were adding the moment of inertia. That means moment of inertia can be added and subtracted. And I remember somebody in the class saying, this triangle one, I want to do whole triangle minus this. Yes or no? I heard somebody saying in the class the other day, right?
Yes, sir.
Yes, sir.
Yes, sir.
Correct? So I can add the moments of inertia, I can subtract the moments of inertia. Yes or no?
Right, sir.
yes, sir.
So what am I going to follow? Whole minus loss. So see, these are the steps you write what I'm writing now. ICL of the whole water plane minus ICL of the lost water plane. Will it give me ICL of the intact water plane? Yes or no? Tell me, guys. Look at the lower diagram and tell me.
Yes, sir.
Divided by volume of displacement. Now, after writing this one formula, then expanding it here, now I'll write the values in the notational form. Look at the diagram of water plane area. tell me what will be the ICL of the whole water plane in the notational form.
Capital B square.
capital B square upon 12D.
ICL.
LB cube upon 12.
कौन यार कौन
Yes,
सी दुनिया में तुम where are you focusing? I don't know.
So they are giving formula that square 1, 12 square.
No,
B square.
but they can give whatever they're giving. They have to give what I am asking.
Yes, sir.
If you want to answer what you want, then MMT will give you the result what they want then. What is this argument? They are giving this formula. I am saying what is ICL of the whole water plane? You are saying B square upon something. What has happened to your concentrations here? Okay, look at the lower diagram. Tell me in the notational form what will be ICL of the lost water plane.
LB, small l.
Small l.
Small l into B cube
Small l into capital B
upon
cube
12.
upon 12.
Small
Okay.
b cube.
Tell me in the notational form what will be the volume of displacement.
The length into breadth into trough.
Small d.
Small d.
Length into breadth into.
Small
Does
d.
everybody agree? Now it's a matter of putting values and calculating. Next step, I put values 100 into 20 cube by, just keep like this. Don't unnecessarily keep calculating. As I told you, don't unnecessarily keep solving. Now solve after putting all this. You put 6 and you write the value of BM straight. Don't fragment your calculations.
3.889, sir.
Sorry, beta.
3.889, sir.
3.889 meters. Okay. Others can also check.
Yes, sir. 3.889.
3.889.
Okay, please review the steps. We will be repeating more or less similar drill we'll keep doing. And if you have understood this, then I don't think there'll be too many issues coming up. Then we are well set to complete the midship section, the Bilging or GM calculations tomorrow comfortably. Okay, then add it to the KB and subtract. What will be the kg, guys, and why?
Kg will be
Same.
Same. Why? Because we are following loss buoyancy method, right?
Yes, sir. No change in displacement.
Yeah. So please, so GM will be KB plus BM minus kg. What will be the GM in the Bilge condition then?
0.675.
0.675. Okay. Any questions on this? You see, you need to talk to yourself correctly. You need to make use of notational representation. If you use the notational representation, it makes it much easier. If you start putting values from the first step, it will become too messy to handle. And you'll be then running in circles. So it's always advised that you standardize your own notations, continue following them. Water plane area in the Bilge condition. And if anybody has any questions, let me know.
No question.
No questions. Fantastic. So now we have, please find out the sinkage. Write like this. Now I'll tell you. Write like this. Sinkage. Don't write anything else. Talk to yourself. Lost buoyancy. Write down the notational form of lost buoyancy in the numerator. Write down the notational form. Yeah, but write down correctly now, mind. I'll do that. So lost buoyancy is small l into small b into h. And the water plane area under WL is fully intact. So this will be equal to 30 into 20 into 2 upon 100 into 20. So this goes to 3.6 meters, right, guys? Am I right?
Yes, sir.
Therefore, D1 will be equal to 6 plus 0.6. It is 6.600 meters. It goes on the diagram here. Guys, any questions on getting the sinkage and D1?
No, sir.
Okay. Anybody else in the class who feels he still has a doubt?
Excuse me, sir.
Yeah, tell me.
Sir, this sinkage formula is lost buoyancy by intact water plane area.
Yes.
And then in this case, intact water plane area will be capital L into B minus small l into B, right?
When I drew the water plane area, I asked you, what diagram have you drawn? Did your diagram of the water plane match with mine? Yes or no?
Yes, sir.
So then where is the lost water plane in the diagram? I can't see any lost water plane in my diagram. Is your diagram having the lost water plane?
No, but if that is the case, then we are not able to see the sinkage also in this top view.
What?
No, in the second diagram which we have drawn for water plane, that doesn't even show sinkage also, sir. Sinkage is like in the top diagram only where the water plane area is shown.
No. Sink. What do you mean by showing the sinkage? Sinkage you will see only either from the sides or from the ends. How will you see in a bird's eye view the sinkage? How will you see? You will never. You can never see a 3D thing. How can you see sinkage in a bird's eye view? Looking at the deck of a ship from helicopter. No. Tell me. Looking at the deck of a ship from a helicopter, can you tell me the draft of the ship?
No, not possible.
Then, what do you mean by sinkage cannot be seen from top?
No,
I never said. I said sinkage can never be seen from the top, beta.
No, but the formula is like sinkage ka
Yes,
formula.
yes. So what is water plane area to you? What I explained water plane area whenever I started with BM. What did I tell you is the water plane area? How do you visualize the water plane area?
From the top view, it is L into B, capital L into small. Capital
No, I'm asking you something else. How do you visualize the water plane area? I'm not asking in the bilged condition, identical, yes or no. And I'll ask you the reason. Whether you say yes or no, I'll still ask you the reason. Deepak, did you get my question?
No, sir. Just repeat again, sir.
KB will not be d1 by 2. It has to be calculated by moments. Is that clear, beta?
Clear, sir.
Okay, sir.
Understood? Okay. So let's calculate, and we have already learned how to calculate the KB. Now, Deepak, you will answer my remaining questions unless anybody else who wants to participate has doubt in his own understanding. I can rope you in asking. Deepak, first we will take the vertical moment of the whole underwater volume up to W1, L1. So first you tell me in the notational form, LBD and all that thing, what is the underwater volume up to W1, L1?
Capital L into capital B.
Yeah.
Into D1.
Okay, now this is the underwater volume. What will be the distance of the geometric center of this volume from keel, that is the liver?
D1 by 2.
Sure? No, you don't seem confident. You said D1 by 2, but are you sure about it? It is D1 by 2. Answer is correct. But do you know what you're talking, or if there's any doubt?
Yes, sir. Half of the draft. D1 by 2.
Okay, because it's box shaped, right?
Yes, sir.
Okay. Now from the upper diagram, identify the volume which is under the water but not contributing to buoyancy in the notational form. Identify that volume that is under the water but not contributing to buoyancy.
L into B.
Okay, I presume it is small l and b. Am I right?
Yes, sir. Small L into small b.
That is area.
Into H.
Into H. Okay. Sure. Okay.
Yes, sir.
What will be the distance of the geometric center of this volume from keel, the liver?
H by 2.
Let him speak now. Yeah. You don't want your friends to pass, right? You don't want him to learn.
H by 2, sir.
H by 2. When I subtract the vertical moment of underwater volume not contributing to buoyancy from the vertical moment of the underwater volume, guys, the numerator is the vertical moment of volume of buoyancy now. Correct, guys? Yes or no? correct?
Yes, sir.
Divided by volume of buoyancy. Deepak, what is the formula for volume of buoyancy?
L in capital L into capital B into D.
Very good. Now you just put the values and calculate. All of you can do that. 100
3.5.
into
3.530, sir.
okay, good. Okay. Everybody is good up to KB, guys?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now, for BM, we take the water plane at which draft? At the draft at which she is floating. In the Bilge condition, she is floating at W1, L1. So now we deal with this water plane area. Let me use the red marker. Now we deal with this water plane area at W1, L1. The water plane area at W1, L1 is fully intact. Yes or no?
Yes.
Yes, sir.
Yes, sir.
And the center of flotation would be here, needless to say. Then draw 4.5 axis through it, guys. You keep updating your diagram. That's how you will be able to use in the notational form. CL is the center line. Now, I don't think that should be an issue. BM will be equal to ICL of what? Intact water plane. Fortunately, here the full water plane is intact, but I'll write intact water plane upon volume of displacement. And the full water plane is intact. So it will be LB cube by 12 is the numerator. Volume of displacement will be L into B into D. You can put these values and you can get the BM. It is the same as for the intact condition. Whatever BM you got, 6 meters. Add it to the KB of 3.53, subtract kg of 7.5 and get the GM in the bilged condition. Now, obviously, when we talk about the solid material lying inside the cargo hold, we are making certain assumptions. Why? If you don't make certain assumptions, then you'll need more details. Not that you can't solve with details. Yes, you can, but the details have to be then provided. So when we deal with bilging of a compartment which carries solid in it, solid cargo or solid machinery or solid equipment, whatever it is, then there are some inherent assumptions or by default assumptions that we will be making. So you should not be asking me, why are we assuming the cargo is spread like this? Why are you assuming this? Because if you don't want me to assume that, then you have to give me more detailed, specific information. In the absence of specific information, I can only make certain assumptions and solve. Am I clear, guys? Clear?
Yes.
And what are those assumptions that will be by default there unless details are provided? One is cargo is filling the complete compartment. You should not say what happens if it is iron ore, it will not fill up to the deck. It will fill up only lower part. I can't answer that. Then you have to tell me how the iron ore is peaking, at what level is what height. So we will assume that the cargo is filled up in the complete compartment. Okay. Then cargo is homogeneously distributed in the compartment. Now somebody may say, no, no, no. Only on the port side there is cargo, the starboard side is empty. Now then you have to give details here. I don't have the details. I'll assume that the cargo is spread homogeneously in the entire compartment. That means from forward to aft, port to starboard, bottom to top. It's homogeneously distributed. Is that understood, guys? Understood?
Yes.
Cargo remains secured in its location. The cargo is well secured to the ship's hull. And because of bilging, there is no loss of cargo. You cannot say there was such a big rupture, half the cargo has gone into the sea. If it has gone into the sea, then you have to tell me how much cargo has gone into the sea by. If you don't tell me, I'll assume that the cargo remains secured to the ship's hull. And there is no shifting of the cargo. The cargo does not absorb water. Because if the cargo absorbs water, then you'll again have to give me details how much water can be absorbed by the cargo. Okay. And these are the assumptions under which you will be solving these questions. Do you understand that these assumptions, this information is important, and in the absence of information, we will make these standard assumptions, right, beta? Clear?
Yes,
Yes, sir.
sir, just one thing. So in apart from these five, so we can have a comment like water is free flowing in and out. So it is neither getting absorbed or neither it is filling up anywhere. It is just free
What?
flowing.
Sorry. What is the fifth one?
The water which is coming into the bilges is it is free flowing. Means it is coming and going out at the same time.
Otherwise, how will it be called bilging otherwise?
No, that's what I'm saying.
No,
It is not
otherwise, will it be bilging?
no.
So that applies to an empty compartment also. No, why only cargo compartment carrying cargo? How that becomes relevant only if the cargo is there? The water has to go in and come out, then only it's bilging. No, if you have been able to plug the hole, then it's no more bilging, na beta? Yes or no?
Correct, yes.
Now, the term used is permeability. Now, here is the compartment. I'm just taking like this one. Let us say the total compartment has a volume of 1000 cubic meters. If this compartment, let us say the bilging would have filled it up right up to the top. Okay. Now, if this compartment was empty and water comes in, entire 1000 cubic meters is available for the water to occupy. Okay. But suppose I put a solid cargo here, and this cargo occupies 400 cubic meters of space. Now what happens? If this compartment gets bilged, only 600 cubic meters is available for the water to occupy. Yes or no? Correct?
Yes.
Yes, sir.
But the cargo is secured to the ship's hull. What is freely going in and coming in and going out is the water, not the cargo. Cargo remains part of the ship. So that means now the amount of buoyancy that will be lost will be reduced to 600 cubic meters instead of 1000 when it was empty. Yes or no, beta?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
This, how much is available for the cargo to, how much space is available for loss of buoyancy is expressed by the term permeability. And we denote by small p. What is permeability? It is the ratio of free space or free volume in a compartment to the total volume of the compartment into 100. It is given in percentage. It is the ratio of free space in the compartment to the total volume of the compartment. For the example that I have shown you, what is the free volume of the compartment after the cargo is put? 600 cubic meters.
600.
50%.
What is the total cubic? 1000
Into 100.
into 100. So the permeability would be 60%. Is that clear, beta?
Understood, sir.
Understood? So this will reduce the loss of buoyancy, and that is what is called as permeability. We'll take quickly a question, and then I'll give you a question for homework, and tomorrow we will close out this type of question, that is GM of a effect on GM of bilging. And I'll take this MMD question directly, beta. A box-shaped vessel is 20-meter wide. So I'll make it to save on time. I know we are reaching the closing time, but let's not compromise on it. Length is 40 meters. Breadth is 20 meters. And 5-meter deep is floating at a draft of 3 meters. 3 meters is the draft at which it is floating. kg is 4.2. It has a midship compartment 15-meter long. extending from side to side, that means small b is equal to capital B 20 meters with a permeability of 80%. Now, when it is cargo, calculate the GM after bilging. Okay. In such cases, when there is cargo, solid cargo, I prefer to represent like this. So it will keep reminding me that the compartment has cargo. Understood? Understood, guys?
Yes, sir.
This will cause the vessel to sink to a new water line W1L1 and at a new draft of D1. Now, if I visualize the water plane at W1L1, I'm sure you'll agree that when the cargo was not there, this volume would have been entirely lost. But when I visualize here, so when I cut it at the water line, what will I see? I will see the seawater in this space, but in between there will be pockets of cargo. Yes or no?
Yes.
Correct?
Yes.
There will be pockets of cargo, guys. Yes or no?
Yes,
Correct?
sir.
Yes, sir.
And cargo belongs to the ship. Correct?
Yes, sir.
Yes.
So the area occupied by cargo at the water line will be the area of the ship, water plane area of the ship. Yes or no?
Yes, sir.
So that means what will I see? I'll see some pockets of cargo here, and rest around this there will be water. The length of the water plane will be 40 meters. Whole water plane breadth will be 20 meters. Small L is going to be 15 meters. Small b is going to be 20 meters. Now in the upper diagram, I will shade the lost buoyancy in blue. I'm sure all of you would agree this will be the lost buoyancy. Yes or no? Up to D?
Yes, sir.
Yes, sir.
And there will be also some loss of water plane area. Okay. Guys, tell me one thing, just going off track. Let me take you back here. Tell me, if this 1,000 cubic meter compartment was fully empty, then what is permeability equal to? Free volume in the compartment is how much? 1,000 cubic
100.
meter.
100.
100.
Yeah,
Yes, sir.
upon 1,000 into 100 is 100%, right? So when the compartment
Yes, sir.
was empty, we did not talk of permeability, but if I want to relate that to permeability, the permeability is 100% for that
Empty
space.
compartment.
You can say it is 100% or it is 1 if you want to, because 100 upon 1 upon 100 is basically into 100. 100% is what? 100% is basically 1, because if you say 1 as 100%, then 60% will become 0.6. So it's up to you. You can call it 100% or you can call it 1. Anyway, coming back here. Now, we need to calculate sinkage. Now, I am talking to myself and you can listen and tell me. Sinkage would be equal to the lost buoyancy. I look at the upper diagram. The lost buoyancy, if the compartment was empty, would be L into B into D. But now out of this volume, some part is occupied by cargo and hence the lost buoyancy gets reduced. In what ratio? In the ratio of the permeability.
80%.
Why? 80% is free. So that means only 80% of the space is available for the water to occupy. That means the lost buoyancy will be reduced in the same ratio as permeability. Right, guys?
Yes.
Yes, sir.
Yes, sir. Right, sir.
Correct? Divided by intact water plane, which is whole water plane in the lower diagram. Whole water plane is L into B minus the lost water plane. If there was no permeability, the lost water plane would be L into B, but now only part of it would be lost, that is proportionate to the permeability. Yes or no?
Yes.
Please
Yes,
review
sir.
this and tell me.
Sir, in
Yeah,
area, how we are taking permeability, sir?
why? What does the volume made of? Volume is made of areas, correct?
Yes, sir, but like permeability is like space, how much it is containing.
Now I'm just, so at every level 60, 80, same at every area, you will lose that much. That's how the full volume will become 80%. No. What is volume? Volume is integration of areas, man.
Yes.
So if the cargo is homogeneously distributed, then every level you will lose the same amount, now, for each area, right?
Yes.
That's why we made an inherent assumption that the cargo is homogeneously distributed, right?
Yes, sir.
Have you does that answer?
Yeah. Okay.
It is like this, beta. It is like this. If you have a glass at home, okay, when you fill it up with water, full glass gets filled up. Now inside this, now you put one small glass more like this, a concentric glass. Now this is a solid glass.
Yeah, that area will be
Now when you cut it at any place, this much is
that area will
intact,
be also included. Yes, sir.
right? Now does
Yes.
that answer your question?
Yes.
Okay, guys. Tell me now. Is everybody satisfied with the formula for sinkage, guys?
Yes, sir.
Yes, sir.
This P was 1. This P was 1 when the compartment was empty. This P was there that time also. We did not put it. It was, if you put the value of 1, it will become empty compartment, right? Correct, beta? Okay.
Yes,
So
sir.
now we put the values. It is 15 meters by 20 meters. Draft of 3 meters. Permeability of 0.8. Why 0.8? 80% means 80 upon 100, which is 0.8. Is that clear, guys? Okay. Divided by 40 into 20 minus 15 into 20 into 0.8. You can calculate the sinkage and give me the value.
1.2866.
Okay. Okay. Take a couple of minutes, a couple of seconds, 5 to 10 seconds, and see if everybody is satisfied with the application of permeability into the sinkage formula.
So I'm really sorry, sir. I got cut out in the middle. Someone had gone at the door. So can you please explain the formula L into B into D into P? I'm really sorry. Just once, sir. I'll understand.
Beta, you want me to close the topic or not?
Yes, sir. Just once. I'm really sorry. Somebody came up.
Yeah, I'm doing it, but let's not be insensitive to everybody here, please.
Yeah, so sorry. Really.
Let's not be insensitive to the entire class. Okay, because this I'm sounding for everybody, because tomorrow somebody else 3 plus, so this implies D1 is equal to 3 plus 1.286, 4.286, 4.2. It's a MMD question, guys. Simple one. Now, guys, tell me, will KB be D1 by 2? Yes or no?
D1 by 2, sir.
Anybody who feels he is not convinced. If he is not, he can calculate by moments and see.
We'll get same answer.
You'll get the same answer. So guys, the water plane will be like this, whether you cut it 1 meter, 2 meters, 3 meters, whatever draft you cut it. Is it going to be the same as drawn here in the Bills condition? Yes or no?
Yes, sir.
So as the water plane in Bills condition is identical from keel to final water line W1 L1, KB final will be equal to D1 by 2. It will be equal to 4.286 by 2, 2.143 meters. Right, guys? You can save that calculation if you want. Okay, done?
Done, sir.
Okay. Now, what I'm asking you is, in this diagram, now we come to BM. One thing is, for BM is correct. It will be I about a 4.5 line or the intact water plane. Look at this diagram here. This diagram which I am bordering, this water plane diagram. How many different portions contribute to intact water plane?
3, sir.
Three.
3. 1.
One, 2 and the
In
cargo
between the permeability state.
and the cargo
Okay.
correct?
Yes, sir.
Now you see, if I was adding the 2 earlier, then I would have now been required to deal with 3. But if I keep it whole minus lost, it still remains the same. Correct, guys?
Right, sir.
Correct, sir.
So it makes it simpler. Now, you don't have to show it. I'm only doing it for explanation. For area A1, the geometric center would be here. For area A2, the geometric center would be here. And for this cargo, since the cargo is homogeneously distributed at the surface also, the geometric center of the intact water plane of the cargo would be here. So do you agree that this will be the center of flotation? Yes or no?
Yes, sir.
Yes, sir.
So you have to basically then identify the center of flotation. What I'm saying is, here will be the center of flotation. If anybody has any doubts about center of flotation, let me know. You don't have to do all this, no. You just have to mark center of flotation, right? Got it, guys? Then what do? I draw a 4.5 axis through it. Is it the center line of the vessel? Fortunately, yes. So I mark it as CL. Now with reference to my diagram, I write the formula. ICL of intact water plane divided by volume of displacement. Have I written the formula correctly, guys?
Yes, sir.
Yes, sir.
And obviously this will be equal to ICL of the whole water plane minus ICL of the lost water plane divided by volume of displacement. Write like this, the way I'm writing. And now I write in the notational form, whole water plane about center line would be LB cubed by 12. Lost water plane about center line would be, it would have been LB cubed by 12 if the entire water plane was lost. Now, how much is lost? 80% of it is lost.
80%.
So the moment of inertia will also be reduced to in the same proportion, that is multiplied by permeability. Clear, beta?
Correct, sir.
Divided by volume of displacement LVD. And now we put the values. It's 40 meters, 20 meters cube by 12. Small l is 15, small b is 20 cube by 12. Permeability is 0.8. Whole thing divided by 40 into 20 into 3. And this will give you the value of Bm in the Bilge condition. And then Km will be Kb plus, how much is the Bm coming? Please calculate.
7.778.
7.788. 788, okay. Others can calculate and check. Then you have the Kb. You can add Kb of 2.143, subtract the Kg of 4.2, and you can give the Gm. That is the answer to this MMD question, guys. So 60% of permeability is same as permeability of 0.6. I hope this is clear to everybody, so that tomorrow in the exam somebody puts 0.6, then you should not be running all over the place as to how permeability can be 0.6. Because he's not put percent after that. So he's put a pure number, 0.6. That means it's 60 upon 100 is same as 0.6. Is this point well clear? You'll be able to remember this and not miss out on it, guys? Okay, fantastic. Now, sometimes the permeability may not be given in these terms. You may be given some other information and you will have to calculate the permeability. Okay? And once you calculate the permeability, the calculated permeability needs to be used to solve the question. Okay. So in the question, you may have another extra step of calculating the permeability, guys. Okay. If you go through past papers, you may come across something like that. So again, it is
सर 6% मतलब ये 0.6 रहेगा 0.06.
It is not 6%, it is 60%. 60%.
60. Okay.
60 upon 100 is 0.620.
Yes.
60% is what? Percent means what? Per 100, right? 60% is equal to 60 upon 100, and which is 0.6, correct?
Yes.
Okay, guys. So you may have to calculate the permeability. That will be an additional step before you start solving the question then. So there are some terms which you are already aware of. You need to be, you should be able to recall them and use them. One is the density and relative density. You all know. In ship stability, what is the unit of density, my guys?
Tons per meter cube.
Tons per meter cube. Very good. Correct. What is the unit of relative density?
No units, sir.
Very good. No units. Okay. Okay. Then, if I say that RD of a substance is 1.25, what does it mean in terms of density? What does it mean? What is its density? Its density is 1.5 tons per cubic meter.
5 tons per cubic meter.
Yeah, correct. RD, the numerical value of density in tons per cubic meter is same as the RD. Only thing is RD will have no units, but it is only if when taken in tons per meter cube. Okay. So this you learned in 3C, but I don't want to take a chance and for you to make mistakes. Then specific volume. I'm not saying specific gravity. Whether you remember this term or don't remember, it is just to tell you what it is. What is specific gravity? Volume, sorry, not gravity, is 1 upon density. Reciprocal of density is called as specific volume. Okay. Guys, if the density has units of tons per cubic meter, when you do the reciprocal of it, what will be the units of specific volume?
Meter cube per ton.
Meter cube by ton. Okay, very good. So now I have just told you this new term, whether you remember or you don't remember, it's fine. Okay, but as long as you, it's just to say somebody may say, yeah.
Sir, I'm unable to view the screen, sir. I will exit and join again, sir. My name is Narendra.
Okay, when you come back, please let us know, Narendra.
Yeah.
Just one doubt by the time we come. So
Yeah.
basically, when we get any, like say density, like salt water, dock water, or something. So basically, they are pointing out to relative density, or that's a normal density.
When they don't give you units, that will be relative density.
Relative density.
If density
Sir,
is given.
I have joined back and I.
Okay, Narendra. Okay, Narendra. Thanks. When units are not given, RD is given, they will not have units. For density, you will have the units. Why? Because, okay, in ship stability, we may use in tons per cubic meter. But in science and physics, you could be using in kg per cubic meter. Meter. You could be using in gram per cc cubic centimeters. So there can be different units of density depending on for what purpose it is being used, right? But relative density shall have no units, right? And relative density will be equal to density only if the density is expressed in tons per cubic meter. Only then. Otherwise, no.
Okay.
So, guys,
Sir, can you please explain this specific volume once again, sir?
It's a term which is reciprocal of density. That's all, beta. 1 by density, what you get is called as specific volume. Okay. It means how much space would one unit weight of the cargo, in our case, the weight of the unit of the weight is ton. So in our case, if you talk in terms of ship stability, it means how much volume will a cargo of 1 ton occupy, right? But correct. Okay, and you all know that if you take a metal, 1 ton of metal will occupy lesser space. If you take a lighter material, a wood, 1 ton of wood will occupy more space. So how much space 1 ton of cargo, how many cubic meters would the 1 ton of cargo occupy? That is called a specific volume, and that can be obtained by dividing 1 by the density of the cargo. Is that clear now?
Yes.
Clear, beta? Okay.
Yeah.
Then stowage factor, all of you know, beta. What are the units of stowage factor? Cargo work? Cubic meters per ton? Tons per cubic meters per ton?
Yes, sir.
Same as specific volume, but what is the difference? Difference is when you load a cargo in a space, when you load a cargo in some space, then because of the shape of the space, shape of the cargo, stiffeners, etc., you lose some volume of the cargo hold, right? And how much of space is occupied by 1 ton of cargo when it is loaded on the ship in that particular space will be the stowage factor. Am I right, guys? So specific volume will be dependent on the composition or the nature of the substance. Stowage factor will depend on shape of the space, shape of the cargo, and of course the nature of the cargo will be only one of the factors. It will have other contributing factors also. So normally guys, tell me, between specific volume and stowage factor, which one you think would be more?
Specific volume.
Specific volume should be more than the stowage factor of the
Stowage
cargo, is
factor.
it?
No, stowage factor, sir, because it's considered the cargo hold. Volume is with
Yeah.
respect to the cargo.
So
cargo
volume, how can the specific volume be more than stowage factor? In the most ideal situation, when there is no loss of space, the stowage factor and specific volume will be equal. Correct? Yes or no? But if there is a broken stowage, then specific volume cannot be more than stowage factor, guys. I'm asking see, one way could have been I could have just given you the formula, but I'm trying to just make sure that you don't forget all this. Okay. Then all of you know about the broken stowage also. It is the free space after a cargo is loaded where cargo could not, with the cargo, it is the space basically lost. Space lost.
So again,
right?
Broken stowage is a part of broken stowage will be a part of stowage factor, sir?
Yeah, that's correct. That's correct. Yes, absolutely. So specific volume and broken stowage both will be part of the stowage factor. Yes or no? Correct? Correct. Now we come to the formula.
Yes, sir.
Now, let us say a cargo has a density of, let's say, 1.5 tons per cubic meter. What will be its specific volume, beta? Can you divide? Specific volume will be equal to 1 by 1.5 is how much?
0.667.
Okay, 0.667, and units will be cubic meters per ton. Am I right? Correct, guys?
So can you repeat?
Yes, sir.
Yes, sir. Correct.
I'm asking if the density is 1.5, what is the specific volume bit of the cargo? What do you want me to repeat? Tell me. Tell me, what do you want me to repeat? You just can't say repeat. Repeat what, beta? What does this mean? That means whatever cargo this is, 1 ton of this cargo, because of its nature, its composition, 1 ton of this cargo occupies 0.667 cubic meters. Correct, beta?
Yes, sir.
Okay. Now, when this cargo is loaded on the ship, let us say the stowage factor given is 1.2 cubic meters per ton. What does it mean? On the ship, 1 ton of this cargo ends up occupying 1.2 cubic meter space. Correct, beta? Yes or no?
Yes, sir.
Yes, sir.
So when this cargo is put on the ship, out of 1.2 cubic meters per ton, 0.667 cubic meters per ton is occupied by the cargo.
Remaining
And
is
what is the remaining thing? Remaining is free space or the broken stowage. Yes or no?
Broken storage.
Correct, guys. So can you subtract and give me? Point
0.533.
533 cubic meters per ton. And as you rightly said, this will be the broken stowage. Fantastic. And broken stowage is the free space which is available for the water to occupy. Yes or no? Correct, beta?
Yes.
Am I right? Broken stowage is the free space which, in case of bilging, the water can occupy, because that is not actually occupied by the cargo. That is not filled up by the cargo. Yes or no? Yes or no? So out of
Yes, sir.
1.2 cubic meters, out of 1.2 cubic meters, how much is the space available for the water to occupy? 0.533 cubic meters. Yes or no?
Yes, sir.
Yes, sir.
Out of, if this volume was unitary method, if this volume was 1 cubic meter, then this would be the space available for the water to occupy. Yes or no? Correct? Unitary method. Correct? If this volume was 100 cubic meters, the space available for water would be so many percent. Yes or no? Correct, beta?
Yes, sir.
This is what is called as permeability. This is what is called as permeability. So if you have understood, fantastic. If you have not understood, please mug up this. Permeability will be equal to stowage factor minus 1 upon density, or RD, whatever you want to say, divided by stowage factor into 100. And so much is the percentage permeability. Please learn this formula if you have not understood. I tried explaining. If you have absorbed it, fantastic. If you have not, please learn this formula. Is that clear?
Clear, sir.
So if you have not understood anything, forget about it. Learn the formula.
So the question what you have solved, so can you, the answer is, will be 0.533 divided by 1.2 into 100. That is the permeability base. Right?
Yes, yes. The questions that we have done. So now I'm coming to very typical questions on the same GM issue. You see, all this while you have done questions like this, in which either there was no watertight flat, so you had WL and you had W1 LL. Or if you had a watertight flat, the flat was below the water line, like you had a DB, for example. All our questions are falling in one of these categories, this or this, yes or no? Correct, beta? Whether cargo was there or empty, that I'm not talking of that. I'm talking in terms of the vertical extent of the compartment. I'm talking in terms of vertical extent of the compartment. Yes or no? Correct?
Yes, sir.
In both these cases, what happened? The water plane area from between the two water lines was same. And that is why you were able to use the formula that lost buoyancy is equal, the regained buoyancy is equal to intact water plane into the sinkage. You could use that comfortably. Why? That day I did not emphasize upon it because that would have unnecessarily created one more doubt in your minds. But I'm sure now you can connect and say that why we said regained buoyancy is equal to intact water plane into sinkage, because the water plane area from WL to W1L1 in this case as well as this case, it was same in the entire sinkage zone. Yes or no, guys? Correct? Yes or no?
Correct.
Okay. Now we are coming to slightly different situation which can be encountered. For example, we have the same compartment, we have a water line here, and suppose my watertight flat is not very clear of the it is not below the water line, nor is it very clear of the nor is it extending right up to top, and let us say there is a watertight flat somewhere close to it, WL, but above it. Okay. There can be a situation like this, there can be a deep tank or whatsoever, beta, yes or no? Correct?
Yes, sir.
Now, in this case, you compare the two I have drawn on the right, which you are familiar with. Now, in such a case, there comes a problem. Problem is, I will lose this much of buoyancy, no doubt about it. Buoyancy lost will be, I know what I'll lose. But when I regain buoyancy, there can be three situations. One, the water line W1L1 may be somewhere below this watertight flat, depending on how much volume have you lost. Second, it may be right in line with the watertight flat. And third, it may be above the watertight flat. Yes or no? Correct, beta?
Yes, sir.
Why? Because that will depend on how much buoyancy have you lost. Sinkage has to be there to regain the lost buoyancy. So the problem that arises in the question that I have now put on the board here is that by looking at the question, I cannot figure out whether my final water line W1L1 is below the watertight flat or above the watertight flat. Do you agree that that is a problem? Yes or no? That's a challenge?
Yes.
Guys, everybody has understood the problem that I'm narrating before we solve
Yes,
the
sir.
question? Okay. So,
Sir,
yeah.
So one thing, this watertight flat, so which means that sealed, right? Water will not go beyond that, right?
Yeah, of course, like the DB tank top.
Yeah. So there is no damage in that watertight flat. But still, how come the water will go beyond that?
It will not go now. When water line I am talking about, I didn't say water. I said
Yes,
water line.
Water normally it will go. It will be in line.
So how much will the vessel sink? How do you know how much the vessel will sink unless you calculate? Bhai? I'm not talking of water going above the flat. I'm talking about water line. I didn't say water in the compartment.
Okay.
I said final water line W1, L1.
Okay.
The challenge here would be, before you solve the question, to get D1 will be a challenge. So there will be a slight change in getting the calculation for D1. Firstly, I will take this question through an example that follows. But have you understood what is the difference that is coming in this type of issue now? Have you understood this aspect here?
Yes, sir.
Okay. So now let's resolve this particular issue with a question that follows. A box-shaped vessel, 100-meter long, 20-meter wide, kg 7.5, is floating at an even keel draft of 6 meters. So it's the same R standard ship which I have taken in all the questions. Unless the question is from MMD, then they can change. Otherwise, I keep working with the standard ship only. Draft 6 meters. It has an empty midship compartment, 30-meter long, 20-meter wide. with a watertight flat at a height of 6.5 meters. That means my draft is 6 meters. The watertight flat, the H, instead of 2 meters in the earlier cases, now the H has become 6.5. Do you agree with me, guys? Calculate the GM of the vessel after the cargo space below the watertight flat with permeability. So there is permeability here, so I mark cargo of 60% gets bilged. Guys, is the question clear? Read the question. Cargo is there and we have a watertight flat at a height of 6.5 meters. The draft of the vessel in the intact condition is 6 meters. Agreed?
Yes, sir.
Agreed, sir.
Okay. Now, I will not draw the W1L1 until I ascertain whether W1L1 is below the waterline, below the watertight flat. Sorry, my mistake. Whether W1L1 is below the watertight flat, in line with the watertight flat, or above the watertight flat. These can be the three possibilities. I need to first figure out, and then I'll draw W1L1 in appropriate place. If it is below watertight flat, then I'll draw W1L1 below the watertight flat. If it's in line with the watertight flat, I'll draw at 6.5 meters. If it is above the watertight flat, I shall draw it above the watertight flat. Am I clear in what I said, guys?
So, can I repeat three possibilities, sir? One is below, on the line, and
The only three. I'm sure you'll also agree that these are the only three possibilities.
this is the waterline basically, the new D1. Okay.
No, I'm talking about D1 or W1L1 waterline, right?
Correct. Yes, of course.
So in earlier questions, we used to draw W1L1 right away. Now I'm holding back the W1L1. Clear, guys?
Yes.
Yes, yes.
Now, you see. What do I do? First, I tell me this compartment is bilged. First, tell me what is the lost buoyancy. I'm sure lost buoyancy would be what I have shaded. Yes or no? So their lost buoyancy does not seem to be a concern. There is nothing new to learn about it. It's 30 into 20 into 6 into 0.6 permeability. How many cubic meters is the lost buoyancy? Can you please calculate and give me?
2160.
2160 cubic meters is the buoyancy you have lost. Now you see, where will W1L1 settle down? Where the regained buoyancy becomes 2160. If it happens below watertight flat, it will settle there. If it happens in line with the watertight flat, it will settle there. If it does not happen until then obviously the vessel will sink more, sir, and W1L1 will be above the watertight flat. Yes.
Sir, little doubt, sir. This lost buoyancy is up to 6.5 height, na, sir, for this compartment.
But
नहीं नहीं भाई इनिशियल वही है ना
ये कहाँ से डाउट आया भाई? ये डाउट कहाँ से आया तुझे बेटा?
यार ड्राफ्ट 6 मीटर्स है ना तो बॉटम लेवल तक
अच्छा compartment
listen to me. If watertight flat was not there, then you would have counted up to deck, is it?
तब 6 तक काउंट करते सर
तो 6 तो फिर इसमें क्या अभी क्या फर्क पड़ गया? अगर मैंने यहाँ पे एक डेक दे दिया तो क्या फर्क पड़ा उससे? कुछ फर्क पड़ गया क्या? Why should I go up? Lost buoyancy will be from the portion which was contributing to buoyancy in the intact condition, right?
Yes.
Above 6 meters was not contributing to buoyancy in the intact condition. So how can that be lost? Right?
Okay.
That was part of your reserve buoyancy earlier, right? Okay, guys. Now, tell me what will be the shape of the water plane. Now, water plane from 6 meters to 6.5 meter draft. In that range, I'm sure all of you would agree that the water plane will have this shape. Correct, beta? And above 6.5 meters, the shape of the water plane will be fully intact. Yes or no?
Yes, sir.
Yes, yes, sir.
Correct, guys? Like dB, then it will become like dB of 6.5 meters high. Yes or no? Then in the case, in the second case, right? Okay.
Yes, sir.
So now we'll carry out a check. How much would be the buoyancy regained if the ship sinks to the same level as H? Whatever value that comes X, that means what will be the buoyancy regained if the water line is in line with the watertight flat. And then whatever value that comes, we'll compare with 2160, and that will give us the idea where the water line is going to be. Yes or no, guys? Correct?
Correct, sir.
Sir,
Yeah.
sir, first we have to calculate that this last buoyancy is between these point or not. Correct, sir?
That is
6
what
and
we are
6.
trying. That is what we are trying to calculate. What is your doubt? I didn't get your doubt.
Sir, I mean to say like when we are calculating, sir. So how we are taking X, like assuming how we do the assumptions.
No, you can't calculate. If the vessel was at this draft, what will be the displacement of the ship? You can't calculate. There cannot be a hypothetical situation. Why it cannot be?
It can be, sir.
So if I'm saying, if the water line, if W1, L1, though I don't want to mess up my diagram, but what I'm trying to say, let me use a very light shade. You don't mess up your diagrams with that. What I'm saying is, if there is a big if that I have said, I'll use this light yellow. I'm saying if my final water line after bilging is in line with the watertight flat, how much will be the buoyancy regained? I'm just asking how much would be regained. If that is regained equal to 2160, then there will be the water line. If it's regained less, the water line will go above. If it is right, so I'm just carrying out a check, right, guys? So what I'm saying is,
okay. Sorry. Clear, sir. Clear, sir.
Okay, no, it's okay. Never mind. It's okay. I'm changing the color. Don't worry. Okay, next to 6.5 meters, I'm sure the intact water plane will be from this diagram A. Yes or no? This is diagram A. This is diagram A, right? This is my B diagram, just so that I can communicate with you. So, if now what can I write? Buoyancy regained up to watertight flat. I'm sure you'll agree it will be the intact water plane for water plane area A multiplied by sinkage. Sinkage from 6 meters to 6.5 meters will be 0.5 meters, correct? So it will be, I'm sure you'll agree, LB minus LBP. This is the intact area, whole area minus lost area, multiplied by 0.5. So much cubic meter would be regained if the vessel sinks to 6.5 meter draft. Yes or no? Correct, guys? Correct, guys? Yes or no?
Yes, sir.
When I put these values, what do I get? Can you please calculate and give me the volume? Sorry?
820. 820.
Is this okay? My
So right now this 820 for water plane area from 6 to 6.5, correct?
my headphone battery is gone, so I'll not be able to use the headphone, but I'm talking to you on my laptop. So if there's any problem, let me know. Okay. So now,
So this
suppose
is for
this
diagram A, right now.
that is only for communication. You don't have to put A or B. It was only to communicate to you. Okay. Okay. Now, guys, suppose instead of 820, Suppose this value would have come 2500. What 2500 cubic meter? What would that indicate? That
W1 L1 is
About-
below 6.5.
is below the watertight flat. If had it been 2500, yes or no? Correct.
So can you repeat? So I didn't catch the.
I said this 820 instead of 820. Suppose this calculation came 2500. What would that indicate?
W
Is above the watertight flat. Yes or no?
Yes,
correct.
sir.
In this case, it is below.
Here it is 820. That means, in that case, it would have been below the watertight flat. I'm saying, had it been 2500, suppose, in that case, the W1 L1 would be below the watertight flat. Yes or no? Correct?
Yes,
But
sir.
it's not so. What is our value? 820. If it is 820, that means buoyancy regained up to watertight flat is only 820 cubic meters. What is the total I need to regain? 2160. That means my water line will be above the watertight flat. Yes or no?
Yes.
Correct, guys?
Correct, sir. Correct.
Okay. Therefore, buoyancy to regain above the watertight flat would be how much? 2160 minus 820. How much it comes to?
1340.
Sorry?
40.
1340 cubic meters. Okay. Now, guys, what has happened after the watertight flat? The water plane will be as indicated by this diagram B. It will be fully intact. Yes or no?
Yes, sir.
And how much do I have to regain above the watertight flat? 1340 cubic meters. Correct? Yes or no?
Yes, sir.
Area.
Yeah. Therefore, sinkage beyond 6.5 meters will be equal to, I'm sure all of you can see sense into it, 1340 divided by 100 and divided by 20. Yes or no?
Yes, sir.
How much it comes to?
167.
1.67, is it?
Yes, sir. 0.67.
670 meters. Okay. That means the vessel will sink 67 centimeters above the watertight flat, and that is where the total buoyancy regained will become 2160, which she had lost. Therefore, the draft D1 will be equal to, which you can understand now, will be 6.500, up to which you regained 820, plus you sink another 67 centimeters beyond this. So D1 will be equal to 7.170 meters. Yes or no, guys?
Yes, sir.
Yes, sir.
Now, please see this, what I have explained. Let me know what are your concerns. Now, I'll mark my W1, L1 in the diagram. And this D1 is 7.170 meters. This is how. Now, I'll proceed with the question. Have you understood?
L into B cube by 12 minus 0.6 into LB cube by 12 divided by 100 into 20 into 6.
Above the watertight flat, what is the shape of the water plane?
It's intact water plane area.
So then, now you know what mistake are you making?
Oh, direct formula.
You can't dump basics here. Basics cannot be left behind. You have to stick to basics. Otherwise, you'll keep making such mistakes, you know. GM, every time GM we have found. all questions were based on midship compartment. Okay. Now somewhere the books also say they create an exercise, Bilging of a midship compartment, and they calculate GM. And what does it do? It sends a wrong message to the students that GM will be affected only when midship compartment is bilged. No. Just see a ship, beta. If you have a ship displacing 10,000 tons, then it will have some KM, because GM depends on KM. Okay. And now if you load 2,000 tons of cargo at the forward end, how will you get the KM? You will read the KM against 12,000 tons displacement, yes or no, guys? Correct? Speak up. Though the load is going to cause a change in trim by head, yes or no?
Yes.
If the weight was loaded on the starboard side, that will also cause a change in list, yes or no?
Yes, sir.
Yes,
Correct,
sir.
beta?
Yes,
So
sir.
when we say what is the GM of the ship, we actually are talking about the GM of the ship in the upright even keel condition. That means at her high draft, whatever is the vessel's GM, that will be of the GM irrespective of whatever list or trim that she may have. Correct, beta? That is the practice you have been following. Probably we don't realize many a times when we do it. Yes or no? We study the stability of the ship, basically these parameters, in upright even keel conditions. Correct?
Yes.
Yes, sir.
So if the KM and the GM of a ship can change when you load forward or aft, it can change when you load to port or starboard, then obviously you will agree that GM will change even if the bilge compartment was not midships. Yes or no? Correct, beta?
Right, sir.
So do not form any wrong impression that GM का question आएगा तो bilging has to be midship. If I bilge a compartment at the ends or somewhere else and tell you to calculate GM, you should not start jumping in the hall saying the question is wrong. Is that clear, beta?
Yes.
Sir.
Now the ship stability has three aspects. One is the statical stability. Other is the longitudinal stability, or you can say statical or yeah. And third is the transverse stability. What is the measure of statical stability? It is the GM or GZ. What is the measure of longitudinal stability? It's trim. What is the measure of transverse stability? It's list. Now, all three parameters of stability, all three aspects of stability, statical, longitudinal, and transverse, are important. Nobody is saying they are less, one is more important than the other. No. But when you calculate them one at a time. So when you are talking of GM, you don't care of what the trim is and what the list is, because you will be working for upright even keel condition. When you are working the trim, then you don't care whether the ship is listed or not, or how much is the GM transverse of the ship. When you calculate the list of the ship, Suppose I load in number 1 hold on the starboard side. Now this loading is going to change both list and trim. Now when I'm calculating the trim, I will not bother about what change in the list has been made, and vice versa. When I'm calculating list, I'll not bother about what change has it made on the trim. Am I clear, guys?
Yes.
Absolutely clear?
Yes.
Yes.
Yes, sir.
Okay, so be very, very clear about it. So tomorrow you have a question where a non-midship compartment is bilged and you are required to calculate GM. GM will be affected, of course. Whether question wants us to calculate or not is not the issue. But GM would be altered, and if GM is to be calculated, we should be able to calculate the way we have learned until now. And let's see it through this question. Read the question. I have intentionally taken it to the forward end because it doesn't matter to me where the compartment is located. Length 190, breadth 25, at an even keel draft of 9 meters. The compartment is 15.
8 meter draft, is it?
8 meters है 8 meters draft. Okay. 8. One second. There is something that has happened. 8 meters is it? Is this question got confused somewhere? Is it? The compartment 25 meter long. This is misprint here. This is 25 meters because if you see the sum total, this is a typo error, I think. Okay. The compartment is at the forward end and it is 25. Achha, it is length. Sorry, it is not the breadth. My mistake. Sorry. It is 15 meter long, divided into port, center, and starboard. So it's at the forward end. The compartment is here. This is the side elevation. Okay. It is divided into port, starboard, and center. The port and starboard compartments are 6 meter wide. So length is 15 meters of the compartment. Breadth is 1 is 6, second is 13, and the third is 6. I can't show the breadth in the side elevation, obviously, guys. Now, let's do the first part of the question. Only the center compartment is bilged. Okay. Now, I'm sure you'll agree that when this compartment gets bilged, the vessel will trim by head. Yes or no?
Yes.
But that is not what the question wants me to work about. Question wants me to work on GM. So, since I'm working on GM, I'll draw my W1, L1 the way I have been drawing all this while. Is that clear, beta? Clear?
Okay, sir.
Okay. Now, center compartment is bilged. So this is the lost buoyancy. Of course, for center compartment, if I'm making the diagram, the B will be 13 meters. So it is not. For B, it will be 13 meters. Water will rise here also later on. Yes. Now I make the water plane at W1, L1. In that, I can show the 3 compartments. Below this bulkhead, I'll have this bulkhead here. And then I'll have the wing tank, and center tank. Each of the wing tanks is 6 meters wide. And the center tank is 13 meters wide. The length of the vessel is 190 meters. And the length of these compartments is 15 meters. Is my diagram correct, Peter?
Yes.
And for part A,
Yes, sir.
this is the lost water plane. Yes or no?
Yes,
for part A, have I drawn the diagram correctly, guys?
Yes, sir.
Yes, sir.
Okay. Now between WL and W1L1, the water plane is same as drawn. So can you now please find out the sinkage? So we are only solving part A right now, guys. Calculate sinkage.
The 0.342. 342.
Sorry?
0.342.
0.322, is it?
42, sir. 342.
342, okay. If anybody wants help, sinkage would be lost buoyancy, which will be L into B into D. B would be 13 meters in this case, divided by intact water plane area, LB minus LB, which will be equal to 15 into 13 into 6, sorry, 8, not 36, 8, divided by 190 into 25 minus small l is 15 and B is 13. Is this what is giving 0.342, guys? Yes or no?
Yes, sir.
Yes, sir.
So after the bilging of the center tank, center compartment, the draft, when we are saying draft, we are not talking at the ends, we are talking of our height draft, okay? We are talking of even keel draft. So our even keel draft would be 8.342 meters. Does everybody agree with it?
Yes.
Tell me, will the KB be half the draft? Yes or no?
Yes, sir.
Yes. So then find out KB.
That
will be
4.171.
4.171 meters. Yes or no?
Yes, sir.
Okay. Look at the lower diagram and tell me whether the center of flotation will lie on the center line. Yes or no?
Yes, sir.
Yes, sir.
Yes.
So center of flotation will lie on the center line. I draw a 4.5 axis through it. I can call it a center line. So BM will be equal to ICL of intact water plane upon volume of displacement. It shall be ICL of the whole water plane minus ICL of the lost water plane, and fortunately it is the standard axis for both of them. So it will be LB cube, length is 190, breadth is 25 cube by 12, whole minus lost. Lost will be 15 into 13 cube by 12 divided by 190 into 25 into 8. This will give us the BM. How much does it come to? You can correct me if I'm making any mistake.
6.438.
Sorry?
6.438.
438. So you can add KB plus BM, get KM minus KG of 6.8223. How much is the GM coming better than?
3.786.
3.786. I give you 10-15 seconds for everybody to see if they have any questions to ask.
लेकिन सर आंसर में तो 5.933 लिखा हुआ है।
कितना आ रहा है अभी? I don't know, but
3.786. 3.786 is right.
You can correct this because I don't know. This must have been. I must have taken. I don't think I've solved it honestly. Maybe it's left over from somewhere. I don't know. I'll check it again later on. But if you're getting 3.786, then it must be 3.786, right? We can note.
6.438 यही आ रहा है सर।
कितना बेटा?
6.438.
What is that? BM, no?
Yes, sir.
Okay, fine. That's okay. That's okay. I must have made mistake. I don't have the calculation right now. I don't know. You can please speak up. Is 4.1558. 4.158 meters is kb. Now, guys, again, I'm sure you'll agree that center of flotation will be on the center line, and the fore and aft axis will be the center line again. Why? Because the areas are symmetrically distributed about it. Correct? Yes or no?
Yes, sir.
Yes.
Now, in this case, again, yes, BM formula is same. BM is I about CL of intact water plane upon volume. Now, guys, in this case, if you use the lost water plane minus concept, you can use it, but you'll have to use theorem of parallel axis. Then why? Because CL is not passing through the geometric center of the lost water plane. Yes or no?
Yes, sir.
Correct?
Yes, sir.
Guys, have you understood what I'm saying? You can do it. I'm not saying you can't do it. If you want, we can do that and show that also. But in such a question, if your concept of moment of inertia is clear, which I'm sure would be clear now, by now, then in this question you may find that adding the moment of inertia of this intact plane and this intact plane may be easier for me. Yes or no?
Yes, sir.
Yes, sir.
Rather
Yes,
than
sir.
getting
Yes, sir.
entangled with the theorem of parallel axis. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
So anybody wants to do with theorem of parallel axis, you can do it. There's nothing wrong in it. It's only adding few steps. That's all. Correct. If you want to do by theorem of parallel axis, then the distance between them would be 3 plus 6.5. It will be
9.5.
so how much will it be? 13 ka half?
9.5.
9.5.
6.5
And then
plus.
you can, yeah, you'll get the same values. Don't worry. Okay. But I'm sure you'll agree with me that it will be equal to ICL of area A1. I can write like this, and area A2. So ICL of A1 plus ICL of A2 divided by volume of displacement. Correct it, guys?
Correct.
Yes.
What will be the ICL of A1? A1 length will be how much? 190 minus 15. 175, right? So it will be 175 into 25 square cube upon 12. This is this value, guys. I'm sure all of you know now it. Plus length is 15, breadth is 13 cube by 12. This one is this value divided by 190 into 25 into 8. You can correct me if there is any mistake I have made. This is just to familiarize you with some types of questions which could be there, and they can cause discomfort if you are not introduced to them. That's all. Otherwise, once clarity of concepts is there should not be any problem.
$6.069, sir.
Okay. 6.069, you're right. 6.069. So Km will be equal to 6.069 plus 4.158 is 10.227. This will lead us to a GM of minus 6.823, 6.823. 3.404, that means the second answer is correct, right?
Yes, sir.
Second answer is matching. The first one, I don't know what have I done. And I'm sure most of you must be feeling much more comfortable with Bilging Whatever we have covered until now, does this give you some confidence that with whatever practice you need, you'll be able to handle this? Yes or no, guys? Does
Yes,
this
sir.
give you the yeah, okay. Now we come to the last of this time. We have dealt with compartments carrying solid with permeability, right? Now, what happens to a compartment which carries liquid? Now, unfortunately, unlike the solids, where we had made an assumption that the cargo remains in place, secured to the ship, does not apply to the liquid. So the liquid will not remain wherever it was. So how do we deal with such situations? It's very, very simple. Nothing tricky about it. Now, tell me if there is a DB tank, if it is carrying oil and it gets bilged in the way of the DB, what will happen to the oil, guys?
Sir, oil will go out and water will come in.
Yes, yes. So there will be a oil spill. We'll not go into its environmental effect. We'll only limit our discussion to stability. Now tell me, this oil, if suppose there is, let's say, 500 cubic meters of oil in a tank, can you tell me how much time, is there a fixed time that it will take to go out of the hold, yes, or of the tank? Or it can be different in different situations?
Different in different situations, sir.
Okay. What are the factors?
It
Though it
depends
is
on
not.
how much.
Yeah, yeah. No, how much what, Peter? Sorry, say again. Say
It
again, Peter.
depends on how much the bilged area is. If the damage
Okay,
is more,
okay,
the
okay.
more
You are
it
saying,
will.
okay. Is the bilged area the only criteria, or there can be other factors also? Though it has nothing to do with stability. I can see. I never do the thing straight. That do like this and you will get the answer. We don't want to have that approach. Okay. You said
So
whether it's a
density will also.
Yes, sir. Type of
okay.
liquid inside.
So
Liquid
viscosity, head of
density.
the liquid.
Very good, very good. So now we are coming to more reasons, right? So yes, one thing you all said correctly, this oil will seep and will leak out of the ship. And obviously, as the oil goes out, the space created would be filled up by the seawater, needless to say. But this amount of time that the oil will take to completely get exchanged will depend on many conditions. Some of you have already raised. You said about the extent of damage. You rightly said the head of the liquid inside the tank. You rightly said the draft outside, head of the water outside, because that differential will also count. And viscosity of the liquid, very good. You have added more or less everything, barring the fact about the weather conditions. Okay. If the weather is calm, the oil will take more time to escape. If the weather is rough, when you go on the deck better during rough weather during pitching, and you go past the air pipe of your tanks where you may have liquid, you hear that hissing sound as you go past as the vessel rolls. You hear the tanks breathing, air being thrown out and air being sucked in as the liquid is flowing from one side to another. Yes or no? Correct?
Yes, sir.
Yes, yes.
So if the weather is rough and the ship is rolling or the ship is pitching, then obviously the head will also fluctuate and the tank will also breathe and the escape rate will increase. Okay. So besides the factors which you help me listing, you can add weather to it. It is only for you to know. Tomorrow somebody in orals wants to bother you. Not that he may be wanting to test anything, but just to for the sake of good clarity, you should show your awareness about whatever you study. Now oil will escape. Whether oil escapes in half an hour completely, or as oil escapes in one day, or oil takes 10 days to completely escape. But truth would be that a stage would come when the entire oil from the tank would be lost to sea and entire tank would now be full of seawater. Do you agree this is the final outcome? Yes or no?
Yes, sir.
So when we talk about the GM or the stability in such cases, we talk of the stability in the final ultimate condition. What is the ultimate condition? Ultimate condition is when the oil is completely lost and replaced by seawater. So we will not be talking. So why I have addressed this is somebody will again, if I start with that, somebody will say, sir, if the oil takes 2 days to leak, yes, it may take 2 days to leak, but the stability that we are calculating is the for the final ultimate condition. Is that clear, guys?
Yes, sir.
Okay.
Excuse me, sir.
Yeah.
Sir, are you sharing some screen, sir?
No, I'm not. No, I'm just giving a narrative. I'm not sharing. It's only screen is shared with a title on top. Bilging
yes,
of compartment. Yeah. So the screen that you're seeing is the one. I'm in fact walking around in my office and just giving you this narrative, nothing else. Anyway, so have these very basic things always backing your knowledge has to back your performance, but are not the mugging up capability. Okay. Now let's take a case of a vessel and let's limit it to let's talk of a DB only where we started off. So here is a ship. I'll bring it midship only, so don't worry. I'll bring it midships. Now we have already learned if it is at the ends, it doesn't make a difference to us. The ship is floating at waterline. Here is the DB. It is full of maybe fuel oil or diesel oil or whatever you want to say. Ship has a draft D, and now it is bilged in way of the DB. Okay. What will eventually happen? Eventually, what will happen is this oil will be completely lost and this will be all replaced by seawater. All of you have agreed correctly. How would we calculate the GM in such a case? Okay, so let me take you through this example. A box-shaped vessel, 100-meter long, 20-meter wide, kg 7.5, same standard ship that we have been taking, floating at an even keel draft of 6 meters. It has a midship compartment, 30-meter long, 20-meter wide, with a 2-meter high DB. The DB is full of fuel oil, RD 0.95. Calculate the GM of the vessel after the DB gets bilged. So let me make the diagram. Okay. Length of the compartment 30 meters. Breadth of the compartment 20 meters. This is WL. This is the intact condition. Okay. Let's not build the vessel right now, beta. In the intact condition, can you help me in calculating the, of course, if the density is not given, it will be seawater by default or the water. Can you get me the displacement of the vessel in the initial condition, intact condition? What do I multiply with what?
12300.
Yeah, very good. So it will be 100 into 20 into 6, that is underwater volume of displacement, into 1.025, and this will be equal to 123. That's right. The kg of this vessel, okay, is 7.5 meters. Kg of the vessel in the given condition is 7.5 meters. Can you also help me in calculating the amount of fuel oil that it has in the tank, concerned tank? I'm sure you'll agree that 30 into 20 into 2 into 0.95. How much you said?
1140.
40 tons. What will be the kg of the fuel oil, guys? 1 meter?
One.
Agreed? Okay. Now, before we discuss further, let's create an imaginary condition. Let's have intentionally pumped out this fuel oil. The ship is intact. My ship is not yet bilged. And now what do I do? Now I have a ship in which everything else is same as it was. Only change I have brought about is I have emptied the concerned compartment, which is DB in this case. That means I have intentionally pumped out 1140 tons of cargo or 40 tons of oil from the DB. So now, what will be the new displacement of the ship if I imagine to have pumped out this one?
The rate of initial displacement minus rate of which is thrown out.
Yeah, so,
1160.
so it will be 12300 minus
Triple
1140,
160.
triple
Triple
one
one six.
60 tons. Okay, very good. Now, can you find out the draft of the vessel in this condition? Draft of the vessel in this condition, it's a box-shaped vessel, so it will be 11160 divided by 1.025 divided by the length and divided by the breadth.
5.443.
5.443 meters. Everybody good with the draft?
Yes, sir. 5.443.
Okay. Will the kg also change, beta?
Yes, sir.
Yes, sir.
When I
It will
pump
change.
out something? Yeah, so what will be the kg in the intermediate condition? It will be initial vertical movement, that is 12,300 multiplied by 7.5 minus the vertical moment of the weight discharged. Weight discharged is 1140. Kg of it is 1 meters divided by the final displacement of 11160. How much is the kg, beta?
8164.
81
8.164
164 meters. Everybody is aligned with me, guys.
Yes, sir.
Yes.
Okay, very good. Now let me draw, like I have drawn this ship, let me draw this imaginary condition. We call this as intermediate condition. This imaginary condition, we call it as intermediate condition. Okay. In the intermediate condition, if I draw the ship now, the length of the ship is same as before. Breadth of the ship is same as before. But now she is floating at a draft of 5.443. Yes or no? Our water line now is at 5.443. She has a DB tank of height 2 meters, but now the 2 DB tank is empty. Yes or no?
Yes.
And kg of the ship in the intermediate condition is 8.164. Yes or no?
Yes.
Yes, sir.
Okay. Now you compare these two ships. One is this initial intact condition, and second is this so-called hypothetical intermediate condition. Hypothetical, we are not actually discharged, right? In these two ships, what is the difference? Rest everything is same. Only difference is here the DB is empty. Here the DB is full of fuel oil. Is that the only difference, or there is any other difference? This has led to whatever difference in kg and all those things, right? And draft.
Yes, yes.
So what is the difference in condition? The differentiating aspect is the DB. Yes or no, guys?
Yes, sir.
Okay. Just for the sake of discussion, let me call it as ship A and let me call it as ship B. Ship A and B are same ships in same condition. Only thing is, in one case, the DB is full. Rest all the weights are in the same place in both the ships. Only thing is, in ship A, DB is full of fuel oil. In ship B, DB is empty. Both ships are intact. Okay, guys. If now this one gets bilged, based on our discussion a while back, after some time, what will happen? This fuel oil will be lost. Correct, beta?
Yes, sir.
Yes, sir.
And I will have this ship A floating at a certain draft W1L1. I don't know what that would be. In which this is ship A after bilging. Bilge condition. DB is empty, and now this DB is full of seawater. Correct, beta?
Yes, sir.
Correct? Yes or no?
Correct, sir.
Yes, sir.
Okay. Now, if this ship also gets bilged in the way of the DB, what will happen? This ship will also sink to a new draft, some new draft. And in this case, as the DB, she will also float at a new water line for her W1L1. In this case also, what will happen? The DB will now be full of seawater. Correct? After bilging.
Yes, sir.
Yes, sir.
Now, if you see these two ships, now whatever I am binding in blue, this part of the ship and this part of this ship, they are in the same condition. The blue parts of both the ships are in the same condition. Yes or no?
Yes, sir.
When they were A and B before bilging, the differentiating factor was the DB. Now their DB has also become in the same condition. Yes or no?
Yes, sir.
Correct.
So that means both the ships are in the same condition post bilging. Yes or no?
Yes, sir.
Both
Yes,
the
sir.
ships are in both the ships are exactly in the same condition after bilging. Yes or no?
Yes, sir.
So that means whatever is the draft D1 here would be the draft D1 here. They will both be same. Yes or no?
Yes, sir.
Whatever is the GM in the bilge condition here, same would be the GM here because they are exactly in the identical condition after bilging. The difference was before bilging. After bilging, both have come to the same condition. Yes or no?
Yes,
Yes,
sir.
sir.
So now you all know how to build this condition. Empty. I can read this question differently now. A box-shaped vessel, 100 meter by 20 meter, kg 8.164 at a draft of 5.443 has a DB which is empty. Calculate the GM of the vessel after this DB gets bilged. So you will be basically finding the GM for this vessel. Yes or no? Correct?
Right, sir.
Yes, sir.
Yes,
And
sir.
you have already agreed this GM will be equal to this GM.
Hmm.
Correct, sir.
Yes, sir.
You have already agreed to that. Correct? So when it comes to handling a compartment which has a liquid, we first go to an intermediate condition in which we assume that the liquid has been intentionally pumped out in the intact condition. You empty that compartment first and come to new draft, new kg. Come to the new condition with that compartment empty. And now once that compartment is empty, you have done so many questions where the empty compartment was bilged. Yes or no?
Yes,
Yes,
sir.
sir.
Have you understood what I said, guys?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Basically, can I clear this screen? Unless somebody has a question to ask, then I can tell you I can just list down the steps involved. I've explained to you why these steps are mandatory. Draw diagram of vessel in given condition. In intact condition, in given condition, given intact condition. Okay. Do not mark W1, L1, etc., etc. on it. Second, work out an intermediate condition assuming the liquid in the concerned compartment having been pumped out. In case of GM, what all you need to calculate? You need to calculate the draft of the vessel and calculate the kg of the vessel in the intermediate condition. So that means third, obtain draft and kg in intermediate condition. Now, fourth, bilge the vessel in intermediate condition. Bilge the compartment, right? And get the GM or whatever is required. And that is the answer to the question. Obviously, beta, needless to say, when you get sinkage in this case, you will add sinkage to the draft in the intermediate. What was the draft in the intermediate condition? Can you tell me, guys? Intermediate condition draft was
5.443.
okay, and kg
164.
8.164. Okay. So now, when you now let's do this question. It is very simple. Then let's do this question here. Let me
So
change
what
to
is the
blue.
second point? The second point about
Work
that.
out an intermediate condition, assuming the liquid in the concerned compartment having been pumped out, beta. Okay. Got it? Got it?
Yes, sir.
Okay. So now I'm drawing the intermediate. So now draw your vessel in the intermediate condition. Forget about the initial condition now. Length 100 meter, breadth 20 meters. WL here. Draft 5.443. kg 8.164. You have this compartment empty. H 2 meters, length 30 meters, breadth 20 meters. And now we build this compartment. Now in this compartment, I'm sure you'll agree, this will be the lost buoyancy. Yes or no, guys? Correct?
Yes, sir.
And ship will sink to a new water line W1, L1. And the water plane between WL and W1, L1 will be fully intact. All of you agree with me, beta?
Yes, sir.
Okay. So now we can find out the sinkage. Sinkage will be equal to lost buoyancy, that is 30 into 20 into 2 divided by the intact water plane. Full is intact. 0.6 beta.
Yes, sir.
So now your D1 will be equal to, it will be added to 5.443, guys, which you can see there is nothing much to explain on that. It's a obvious outcome. 6.043 meter will be D1. Have you understood what I have said, beta?
Yes, sir.
Yes, sir.
Understood, sir.
Okay. Because you are building now this, you forget about the initial condition. Now, KB will not be half the draft, so let's calculate KB. KB will be equal to, after bilging, underwater volume, that shall be equal to length into breadth into draft of 6.043 into half of it, 6.043 by 2. This is the vertical moment of the underwater volume minus the vertical moment of the volume not contributing to buoyancy, that is 30 into 20 into 2 into vertical lever will be 2 by 2, that is 1, divided by 100 into 20 into 6. Can you calculate and give me the KB, beta?
3.2443.
Yeah, tell me, any questions?
100 into 20 into 5.443
आएगा ना सर?
Okay, okay, एक minute. Why underwater wall? अरे तो underwater wall D1. What is the D1?
नहीं सर, नीचे जो नीचे लिया है,
जो नीचे लिया सर आपने,
नीचे कहाँ पे बेटे?
नीचे तो 5.44 आएगा ना
100 into 20 into जो 6 लिया सर आपने,
Denominator will be 5.44.
जो volume की जगह
Okay. Sorry, my mistake. Thank you for correcting. Thank you, my mistake. Okay, I thought you were saying here.
3.244 सर आया।
कितना आया? Sorry, my
3.243.
वही सर 3.24244 या 43।
Okay, 243. Okay. Thank you for correcting here. Thank you for correcting. 5.443. You're right. Absolutely right. Okay. Now BM, this full is intact. So center line, BM will be equal to, it will be LB cube, 100 into 20 cube by 12. Volume of displacement will be length 100, breadth 20, draft 5.443.
6.124 sir.
6.124. Okay. Now
GM is 1.204.
Okay, this GM would be this plus this, so 3.243 plus 6.124 minus this kg, guys, minus 8.164. And what is it that you're getting?
1.204.
204 meter. This is the answer to this question. So for liquid cases, this is the route you'll have to take. You'll have to work out an imaginary intermediate condition, and then you will be able to close it out. Second thing that compartment would do is it will cause the trim to change. It is like loading something in number one hold. It will change the GM and it will also change the drafts. And we are assuming it is loaded on the center line. We are not talking about the list. If it is bilging takes place on the side, then of course that is also going to cause the vessel to list. But the list questions are not in your syllabus. They are simple, again, continuation of the same thing, but they are not part of your syllabus. Okay. Now, today we will focus on this. This part is already done. We are not going to bring this into our discussion anymore. Now, our focus will be, this will be the focus area today. How do we get the draft forward and aft? So, shall we continue?
Yes, sir.
Now, first, let's recall the formula for trim. I'm sure all of you know that if the trim of a ship in centimeters is equal to LCB difference LCG into the displacement, which is the trimming moment of the vessel, divided by MCTC. Some of you may be writing it as BG into W upon MCTC. I'm sure all of you are familiar with this formula, guys. Yes or
Yes.
no? Okay. If LCB is initial, LCG is initial, displacement is initial, MCTZ initial, then you will get the initial trim. Am I right, guys?
Yes.
If all these things are in the final condition, that will give you the, so what I'm saying is, if all these components are initial, in our case, initial is before bilging, then this will give you trim before bilging. Yes or no? Correct, guys? Correct?
Correct, sir.
Yes, sir.
If all these particulars are final, that is after bilging, you will get the trim after bilging. I don't think there should be any confusion about it, right? Okay, fantastic. So that means if after bilging I can find the ship's LCB, if I can find the ship's LCG, I can find the ship's displacement, I can find the ship's MCTC, I can get the trim after bilging. Yes or no, guys? Correct?
Yes.
Fantastic. Now we'll just simplify this formula one step so that every time we don't have to spend more time. Formula is perfect. We'll simplify this formula for our use so that every time we don't have to calculate MCTC, another one step getting into place. Guys, what is the formula for MCTC? MCTC is equal to W into GML upon 100L. I'm sure some of you may be able to now recall it, right? Correct, beta?
Yes, sir.
Correct.
Okay. And what is GML equal to? GML equal to KML minus KG, right, beta?
Yes, sir.
And what is KML equal to? KML is equal to KB plus BML.
BML.
And minus kg, right? So now, sometimes, so that means for getting GML, you need to know the kg of the vessel, yes or no? Correct?
Yes, sir.
Sometimes the kg may not be given in the question. Sometimes the kg may not be given in the question. I'm getting an echo from somebody's system, better. Can you please mute yourself? Okay, thank you. Okay. Sometimes if the kg is not, if kg is given, then you have to use this formula what is on display, right? If kg is not given, then you see, if you don't use subtract kg, then you can also maybe not add AB, kb. So that means the error because of leaving out both kb and kg, the difference between BML and GML will not be appreciable. It will be a couple of meters only. Why? Because kb, kg, they differ usually on a ship by about 2-3 meters. Okay. So the error between BML and GML would be to the tune of a couple of meters only. So if I don't have kg, it is only if I don't have kg, then in lieu of GML, I can use BML, and then this formula can be written as W into BML upon 100L. Okay, guys? Understood?
Understood.
Okay, now, if I put this formula for MCTC in the trim formula, we just wrote trim is equal to, I'll use this one for just running, keep it short, upon MCTC. If I put the formula of MCTC here, W into GML, and 100L will go in the numerator, W get cancelled out. And then I can say this it's the same formula for trim. I've not changed it. I've not changed anything. Only thing is I'm just trying to cut a short of for saving the time on calculation of MCTC. So the trim in centimeters is nothing but BG into 100 into length of the vessel upon GML. Yes or no, guys?
Yes, sir.
Okay. What will happen? Then once I get GML, I don't have to make extra effort to calculate the MCTC. I will save a step. Okay. So this is the formula we'll be using to calculate the trim. If I do not have the GML, instead of GML, as I've already explained in the MCTC formula, the formula can be used like this. Any questions on what I have said until now, beta?
Nothing.
Because I have to customize my explanation based on what questions the batch comes up with. So it cannot, it's very difficult to just put it down and then say, now. So if you see this, to get the drafts forward and aft, what will I need? One, I'll need the, after bilging, the ship's height draft. Two, I'll need the trim. And three, I need the LCF. Okay. What is height draft? Height draft is the draft after sinkage. So this is the D1 that you all know. Correct, guys? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now to calculate the trim, we have seen this formula. We need LCB after bilging. We need LCF, LCG after bilging. We will need length of the vessel, and we'll need BML, preferably GML or BML, one of the two things, right? And then all these things can go in the formula and can give us the trim. And all these things calculated can give us the drafts forward and aft. So basically our exercise would be to calculate all these things which are in the blue now. What are they? Sinkage and get D1. Decide on the ship's LCB after bilging, LCG after bilging, length of the vessel, preferably GML if kg is given. If kg is not given, you can use BML after bilging, of course. This is post bilging values, and the LCF of the vessel after bilging. Once I am able to get all these things one at a time, I just need to put them in the formula, get the trim, split that into TATF and apply to the height draft. And that will close my question. Do you all agree with the steps involved, guys?
Yes.
Please have a good look at what is written. It's all reasonably clear on the screen. If you have any doubts, let me know. Then we'll get going with the question. Forward bulkhead is now straight away what I've done. I've taken it somewhere else. I'm not going to keep it at ends and then bring somewhere else. It's all they're all same. The forward bulkhead of the compartment is 10 meters from the forward end. If this compartment with permeability, all this we are familiar with, is of 30% is bilged, calculate after bilging the drafts forward and aft. Okay, just give me a minute. If the mail is ready, let me just send out a mail, guys. Now, can you please draw this vessel's diagram? See where the vessel compartment has to be put. See what has to be done. Can you please make the diagram? I'll make it and then you can compare. If you're okay with it, then fantastic. Then there's absolutely no problem. Okay, box shape, yes. Make sure you use the notations, beta. Don't miss out on the notations. Let's say this is the forward end of the ship. This is the aft end of the ship. It could be either way. That's your choice.
Sir?
Yeah.
Sir, just one small question, little bit of nonsense type. Sir, it
Shade the lost buoyancy. And now I'm drawing the high draft water line. I'm drawing, I know vessel will be trimmed, but I'm drawing a even keel condition because I need the high draft only. Water will rise in this space also. And now beneath this, please make the water plane as you have been making earlier. Make the water plane better. At W1, L1, right? And incidentally, it is the same from WL to W1, L1. This is 10 meters. This is the lost bulk water plane. Excuse me. Length is 30 meters. Small b is equal to also 20 meters and length is 100 meters. I'm sure all of you would have made this, guys. Any questions until now, guys?
No, sir.
Okay. Please write down in the notational form and calculate the sinkage. Don't cut short, write in the notational form first.
Sinkage 0.593.
While 0.593. 553, is it?
593, sir.
593. Okay, two people are saying must be correct then. Okay. What will be in the notational form, beta? Upper diagrams give me lost buoyancy. It is L, B, T into permeability. Lower diagrams gives me the intact water plane area between WL and W1, L1. It is LB minus LBP. And when you put these values, I'm sure, is this what you have done, beta, or something else?
Yes,
Sir,
sir.
with this one, I'm
As 6.593. So one thing I've already got now, D1 is equal to 6.593. I'm writing now the things as I need to calculate. In our earlier discussion, what else do I need? I need the LCG of the ship in the final condition. I need the LCB of the ship in the final condition. I need the LCF of the ship in the final condition. And I need the BML of the ship in the final condition. These are all final bilged condition values, right, guys? Am I correct?
So just one doubt. 6.593 is our high draft, right? After the.
Yes, that's correct. Even
Okay.
keel draft, no?
Even
Even keel draft is high draft only, correct?
Yes, sir. Correct. Thank you.
Okay. Is that okay, beta? So I need to calculate these things. Okay. Now tell me, guys, which method of damage stability are we using?
Lost buoyancy.
Okay. In the lost buoyancy method, what happens to G, center of gravity of the ship?
Unchanged.
Unchanged. So if G does not shift, so is there any reason for LCG to change?
No, sir.
No, LCD will remain same.
So the
No.
guys, LCG final will be equal to LCG initial, and I'm giving the reason in bracket, lost buoyancy method. Am I right? Now don't say what happens if it is trimmed. Don't worry. Let's just talk about the question at hand. Okay. Can you read the question again and tell me what do you think would be the relationship between LCB of the ship and LCG of the ship before bilging?
So equal. Same, sir.
Why?
Equal, sir.
Reason?
Okay.
Give the reason.
Even keel.
Even zero trim.
Because no trim.
Okay. So now LCG initial will be equal to LCB initial. I'm giving these reasons, and you have to write this if you want to cut short. Because vessel is even keel in intact condition. Am I right, guys? Agreed? Correct?
Correct, sir.
What is the shape of a vessel?
Box shape.
For a box-shaped vessel, what is the LCG? What is LCB equal to? What is the LCB equal to for a box-shaped vessel?
Half of a length.
Okay. And what is KB equal to?
Half of draft.
Half of draft.
Half of draft.
So the moment I remind everybody half of draft, now everybody will accept half the length, right? So good. LCB initial will be equal to L by 2 because we are talking of box-shaped vessel. Do you all agree with these three statements I've written? Am I right, guys?
Yes, sir.
If you combine all three, what does it mean? LCB initial is equal to LCG initial. That means LCG initial is L by 2. LCG initial is equal to LCG final. That means LCG final is L by 2. So that means LCG final of the vessel will be L by 2. And in our case, it will be 50 meters. Do you agree with this calculation of LCG?
Yes, sir.
Correct, guys?
Correct.
So now I have to calculate these. I'm putting 50 meters here. Now I have two things. D1 and LCG are already computed. Happy? Okay. Now we calculate LCB final. You all know how to calculate KB. We have done it on all the questions on day before yesterday and yesterday, right? KB after Bilging you have been calculating. Yes or no? Correct?
Haji sir.
Yes, sir.
You were taking moments about when you are calculating KB.
E.
Now for LCB, you will take moments about which axis.
Half, sir.
Half.
Half perpendicular.
So everything remains exactly the same. Only thing is, whatever you are talking to yourself, instead of keel or vertical moment, use the word after perpendicular if you're using keel earlier. If you're using vertical moment, use the word longitudinal moment. Means I need to get the longitudinal moment of volume of buoyancy, right? Correct, beta? Yes or no?
Yes, sir.
Yes, sir.
Guys, how do you get LCG? For LCG, you take the moments of the weight about after perpendicular, yes or no?
Yes, sir.
So here we'll take the moments of the volume about after perpendicular, correct?
Haji sir.
CB. Yes, sir.
Okay. So now I will speak to myself. You will look at the diagram and tell me in the notational form. Don't worry, some of you will understand faster than the others, but that always happens in a class, so not to get worried about it. I am saying LCB final is equal to, I'm saying longitudinal moment of the underwater volume up to W1 L1. KB mein what statement were you making? Vertical moment. Now what statement have I made? Longitudinal moment. Correct, guys? Yes or no?
Yes, sir.
For which first you'll have to for which you'll have to first identify the underwater volume. Tell me in the notational form what is the underwater volume in the Bilge condition? Very good. Very good. Stop here. Very good. What will be the lever of the geometric center of this volume from after perpendicular? Look at the diagram and tell me.
L by 2, sir.
50.
L by 2. L by 2, notational form. Let's not talk of numbers. Simple, guys.
Yes, sir.
In the
Yes,
earlier
sir.
calculation, it was D1 by 2. Now it has become L by 2. That's all that has happened. Correct?
Yes, sir.
Correct.
Minus the longitudinal moment of the volume that is under the water, but not contributing to buoyancy. So first identify from the upper diagram in notational form, what is the volume that is under the water but not contributing to buoyancy? First tell me in the notational form that volume.
B. L into
Small L, small
small
L,
L into
Small
small
L
B into D1.
T1 into P.
E1.
T1.
Into
Right, guys? Correct?
Yes, sir.
Okay. Don't give me the note. There is no notation we have put. But where will be the geometric center of this volume? The geometric center.
L plus
You don't have to draw it again. The geometric center of this volume would be here. Yes or no? Correct,
Yes,
beta?
sir.
Yes, sir.
Let us say this distance is x.
75.
Yeah, put the notation and put the value here, 75. How? It is 90 meters up to the forward bulkhead. Another 15 meters goes from there. X is equal to 75 meter. Does everybody agree? Correct, beta? So that means this underwater volume not contributing to buoyancy, LBD1P, will have a longitudinal lever equal to x. Yes or no?
Yes, sir.
Correct. This will be the moment of that volume about after perpendicular. Correct, guys?
Yes, sir.
Yes, sir.
Divided by volume of displacement. What is the formula for volume of displacement?
L into B. B.
L into B into D.
LBD. Put the values, calculate. You get LCB. Please do the job and give me the LCB. Simple, guys. If you know the earlier stuff, I don't think there is much to learn, right?
Yes, sir.
Sorry, my mistake. Calculate and confirm when everybody is done. Three of them are already calculated, right? Now, LCF in this case, tell me, if I was to get KB in this case, would KB be D1 by 2, yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
For the same reason, same thing, you already know when KB will be D1 by 2. If KB was to be D1 by 2, then in such questions, LCB and LCF would also be equal. LCF initial, LCF final. Why? And this will also be equal to 47.525. Why? Because the water plane area in the bilged condition from keel to the W1L1 is identical and therefore it will be same. Okay, so if this is clear to you, you can cut short. Nevertheless, we'll calculate the water plane area now also. As we said in case of KB, if you're in doubt, please calculate. In case of what LCF also, if you're doubtful, please calculate. Otherwise, if you're clear, then either you can calculate LCF and equal to LCB, or you can calculate LCB equal to LCF. Choice is yours. Let's calculate the LCF, which of course will be same. There may be a slight variation in the last number, one up or one down because of rounding of issues, else none. Okay. But LCF, that is the center of flotation, is the geometric center of the water plane area. So first tell me, when I have to calculate the LCF, is it the upper diagram which is relevant or the lower diagram which is relevant?
Lower.
Lower one, sir.
Because
Lower.
that is dealing with the water plane area, correct? Okay. Now, in phase one, when you're doing Simpson's rules, what were you doing for LCF? You're getting the moment of the intact water plane about the after perpendicular, dividing by the water plane area.
Yes, sir.
Same thing we'll do here. Only thing here, full is not intact. So we'll make it whole minus lost. So we'll take the moments of area. In LCB, we took longitudinal moments of volume. In LCB, which is on display here, we took the longitudinal moments of volumes. Now we'll take longitudinal moments of area. And our eyes would be on the lower diagram, beta. LCF final, now you will tell me, is the longitudinal moment of the whole water plane. So tell me, what is the whole water plane in the notational form?
L into B into L by 2.
L into B is the whole area and its liver will be L by 2. Very good. Minus the lost water plane longitudinal moment of the lost water plane. First identify the lost water plane.
Small L into small b
Into P.
into P.
Where will be the geometric center? It is at the same in X. The distance is same here again. X is equal to 75 meters. So liver will be X divided by the intact water plane. Intact water plane will be, guys, principal of moment,
L into
LP minus
minus
LPP.
LBP.
Put these values and you will get it back to 5.25 meters. So if you have any doubt, you please calculate. And if they are not going to be equal, in any case, you'll have to calculate them. The problem is with the LCB. If this is coming 7, then 7 is correct. What will happen, I'll tell you. Instead of this LBD, if here you use LBD1 minus LBD1P, and calculate, you will get this also 7. So it is 47.527, which will be actually correct. Try this one bit ekbar on the run.
Yes, sir.
Yes, sir. 47.527.
Also, now what is left is BML. I'll take this entire thing to the next slide because I'll have to draw a bigger water plane so that you guys don't get confused. I can do on this, but it will become messy because there is already LCF worked beneath it. I'll just take it onto the next slide. Now we have to calculate only BML, guys. That's all we have to do. Rest everything is in place. And BML or BMT, we know it has got to do with the water plane area. So I'm going to draw the water plane area in the bilged condition. You have to explain, that's why I'm coming here. This was our forward end. This was our aft end. This was the forward bulkhead of the compartment. This is the after bulkhead of the compartment. This distance is 10 meters. This length is 30 meters. This breadth is 20 meters. Overall breadth is also 20 meters. Length of the water plane is 100 meters. And you have permeability here. Have I drawn correctly everything, guys?
Yes, sir.
Okay. First, tell me, what is the formula for BML? Recall the formula for BML first.
Moment of inertia divided by volume.
Square upon
Yeah.
20.
Fair moment of inertia, bol diya.
Passing from F on the earthward shift direction.
Of what? Moment of inertia of what?
Of intact water plane area
Yeah, so
passing
yeah.
through
So
in
it is,
upward shift
yeah.
direction, passing through center of flotation.
Very good. Yes, very good.
Direction, yes.
Very good, very good. So now we all know that center of flotation would lie on the center line, yes, though we don't have the relevance of center of line. But we calculated LCF as 47.525. That means 47 meters from the after end, somewhere here, you will have the center of flotation. And this is the axis FF that is of interest to you. Yes or no? Correct, guys?
Yes, sir.
And this is the distance. Now I'm loading my diagram because if I load my diagram, it becomes easier for me. This is 47.525 meters LCF. Yes or no?
Yes.
Any questions until this point, beta? Okay. Now I'll write with reference to my diagram, I'll write the formula. It will become IFF of the intact water plane. Okay. Divided by volume of displacement. This in turn will become IFF of the whole water plane minus IFF of the lost water plane. Correct, guys? Correct? Divided by volume of displacement. Any problems with this?
No, sir.
Okay. Now tell me, is FF passing through the geometric center of the whole water plane? Yes or no?
No.
No, sir.
So that means we cannot directly use the standard formula. Yes, that's what you're saying. Correct?
Yes. Correct, sir.
So that will be 50 meters from after end. Here will be the geometric center of the rectangular portion, 50 meters from after end. And I'll have to draw a parallel axis. Maybe I can call it XX. And this distance, you know, is 50 meters. Correct, guys? Am I right?
Right.
Yes, sir.
Yes, sir.
This will give you the distance between these two parallel axes. Maybe I can call it as D1. D1 will be equal to how much then? 50 minus 47.5, 2.273. Load your diagram the way 473. Okay. Please load your diagram the way I'm loading. Otherwise, you'll get lost in your working.
So can we use another notation other than D1 because it will get
Can we use
Okay,
Y?
okay. Use okay. X we have already used, so you can use X1. Okay, use X1. Sorry, my mistake. Use X1. We should not use D1. You're right. Use X1. Okay, fine. Okay, बेटा.
सर 2.475 आएगा ना?
पता नहीं मुझे नहीं पता तुम ही दे रहे हो यार. बता दो ना एक बार.
475.
475. I'm writing whatever you're giving. I don't keep the calculation in front of me, beta. Otherwise, what will happen? Effectiveness of teaching goes down because then I'll be copying from my register. I want you guys to keep working concurrently. Okay. Now, likewise, is FF passing through the geometric center of the lost water plane? Yes or no?
No, sir.
No, sir.
So that means I'll have to draw a parallel axis there also. Correct, beta?
Yes,
This is the geometric center of this one. I draw a parallel axis. We call it YY. And this distance is 75 meters. You have already told me earlier this was the value of X. Yes or no?
27.
Yes, correct. Correct, guys?
Yes, sir.
Yes.
Correct, sir.
Now
Correct.
this gives us the distance between FF and YY. This one. We call it as X2. Yeah.
27.475.
27.475.
475.
Please mark your diagrams the way we have marked. Then we'll be able to do it. Is the marking of the diagram clear now? You can use pen-pencil combination. Okay, it will be easier for you to handle. Clear, guys?
Yes, sir.
Yes, sir.
Now we will split this. We'll use box brackets and write the theorem of parallel axis. Between FF and XX, can you tell me the theorem of a parallel axis? It will be IXX of the whole water plane
Plus A X1
plus
square.
area of the whole water plane, beta. Don't say area only. Into, from my diagram, it is X1, so X1 square, correct? Minus. I apply the theorem of parallel axis between FF and YY. IYY of the lost water plane plus area of the lost water plane into D2 square. You can correct me, sorry, X2 square. My mistake, guys. X2 square. Okay. Divided by volume of displacement. Is that okay? Does everybody agree with this? You have to follow these steps. You'll never miss out. Correct, guys?
Sir, for the
Yes, sir.
lost water plane, we will use permeability also.
Permeability, sir.
I don't know. You have to tell me what is the loss now. Why this question is coming today? Yeah? What has changed today from last 2 days? Eh? What has changed?
No,
as
in
far as
the formula we will write the P also.
So when we write the formula, then you tell me, na yaar. Let me come to the next step when we'll start writing in the notational form, no?
Okay, sir.
Okay. X of the whole water plane in the notational form, I'm sure all of you would agree, is LB cube by 12. This is the first term. IXX whole. Yeah, I've put the value here. Then area of the whole water plane is L into
BL
B.
cube, sir.
Sir, BL cube होगा ना?
Oh, sorry, BL cube. Sorry. Okay, BL cube. Okay, you write BL cube. I have written L cube into B just to avoid cutting. Please write BL cube. Thank you for pointing out. L into B is the whole water plane into X1 square. Now both these terms, I'll do away with the box bracket now. Minus IYY of the lost water plane. It will be BL cube by 12 into permeability, because moment of inertia will reduce in the same ratio as the permeability. Because of this minus outside the bracket, the other term will also become minus. lost water plane will be LBP into x2 square, whole thing divided by volume of displacement, which is LBD. Does everybody agree? Now I put in the notational form.
Yes, sir.
Now we'll put in the next step the values, and the third step would be on the calculator and answer straight. So we do it like this. B is 20 into 100 cube upon 12, first one, plus 100 into 20 into x1 is 2.475. If you have already marked on the diagram, they become easier to detect. Minus small b is 20, small length is 30 cube by 12, minus 30 into 20. Acha, into permeability is missed out here. Into, please add this into. How much is the permeability? 0.3.
0.3.
Yeah, so please, okay, 0.3 here. Let me change into red from here on. Okay. See, I don't keep my register beta, because if I keep my register, the efficacy of teaching will come down drastically. Into 0.3 minus length 30 into 20 into 0.3 into 27.475 square divided by length of 100 into 20 into 6. This will give you BML equal to something. I'll also calculate on my calculator. You can also keep calculating. Let me calculate now.
127.4.
Yeah, give me a minute. बस मैं भी निकाल ही रहा हूँ. Just give me a minute. Divide by 30.
127.46.
Very good. Okay, shabash.
Yes.
LCG is 50 and LCB is 47. 47.525. So the difference between them will be 2.475 into 100 into length of the vessel is 100 divided by BML just obtained 127.462. This will be so many centimeters. Tell me by head or by head or stern?
By head.
By stern, sir. LCB more than LCG.
LCG ज्यादा है ना सर by head
नहीं LCB is more than LCG, is it? What are the values, beta?
LCG ज्यादा है.
LCG is more than LCB, sir.
LC ज्यादा सर down by head जाए
Okay. So how many centimeters or give me in meters, doesn't make a difference. You can give in meters or centimeters, whatever it is. By head. How many meters?
942 meters.
1 point?
942 in meters.
942.
942.
Yes, sir.
Yes, sir.
Okay. You can split this into TATF using the LCF in the bilged condition, guys. TA will, yeah,
923.
0.923, and this will be, you subtract, so this will be 9.
1.019.
1.019, okay. And these things, because the final trim is by head, TF will be added to the height draft, TA will be subtracted. So last step will be like this: forward draft, aft draft. What is the height draft in the bilge condition? Height draft in the bilge condition was 6.593. 6.593. What is TATF? TF is 1.019. TA is 0.923. She is down by head, so TF gets added, TA gets subtracted, and these will be the drafts in the bilged condition. There will be 2, 11, 1, 6, 7.612, and 0, 7, 6, 5.670 aft. Correct, beta? These will be the
So after 1.942, what have we done? I could not get.
keel to final water line W1L1. LCB final will be equal to LCF final will be equal to 76.071 meters. So we have LCB, we have LCF, we have D1. LCG, by the same logic, LCG final will be equal to LCG initial, will be equal to LCB initial, and will be equal to L by 2, will be equal to 80 meters. Why? Box shaped even keel vessel plus lost buoyancy method. I have summarized all the three statements in one now. Correct, guys? Correct. LCG final will be equal to LCG
Sir,
initial will be equal to
excuse me,
LC.
sir.
Yes.
So only thing this May 2022, the question is a little bit different from this.
I don't know. Maybe
Uh,
it's maybe there are more sets, beta. It's definitely May 22 paper. Maybe
Only
there
thing
are.
they are given that the aft bulkhead is 40 meter aft of forward perpendicular is bilged. So they're given that the bulkhead is aft.
So what difference? So what difference it does it make? Does it make change the question nature?
No, sir, no.
So are we solving a question or are we solving May 22 as are we contesting May 22 or May 23?
You're solving the question, sir. I was just seeing that question paper and I was
So
just
no,
doing.
but what I'm little surprised is when your focus is not on the question, you have gone to see whether this question itself. Now what do I do? LCF I already have, so I'll use red color now. LCF is 76, so it is slightly aft. Somewhere here is the center of flotation. This is FF. Then we have the geometric center of the rectangular portion, G1. We could call it as XX. Then we have the geometric center of this one. We can call it G2. We have a parallel axis YY. This is one distance, which we took X1 in the last one. X1 will be equal to 80 minus 76.071, 3.929 meters. And this will be X2 will be equal to 107.5 minus 76.071, 31.429 meters. Okay, now what does it come? Okay, then we come to LCPML will be equal to IFF, the intact water plane, on V equal to IFF of the whole water plane minus IFF of the lost water plane by V equal to IXX of the whole water plane plus area of the whole water plane into x1 square minus IYY, the lost water plane plus area of the lost water plane into x2 square divided by V. This translates into BL cube. So B is 18, L is 160 cube by 12 plus area is 160 into 18 into 3.929 square minus BL cube. B is 18, length is 15, 25, 25 cube by 12 into permeability of 0.8 minus 18 into 25 into permeability into x2 square 31.429 square. We can solve it and that gives us the BML. Okay.
So one doubt, where are we using the initial KB?
Sorry?
Where have we used the initial, that's 4.7?
What 4.7?
No, the initial kg is given in this question, right?
Yeah. What have you calculated until now? You tell me first. What have you calculated until now?
Yes, till now I have reached the last step. Like almost I'm starting to calculate BML now.
To calculate BML, no? Why are you going left, right? Calculate BML. Why are you hovering all over the place? You guys have very limited concentration span, I can tell you.
$315.435.
Yeah, okay, let me also calculate, then we'll tell it, okay? This whole thing is to be divided by meters, okay? I'll take this onto the next sheet. I have all this, correct?
Yes.
So please get KB 7.314 by 2. If it was not D1 by 2, then you'll have one more step coming in to calculate KB. That will be an added step adding, right? How much it becomes? 3.657 meters, okay? What is our BML, guys? BML is 315.436. This gives us the KML. That is 13, 1, 8, 1, 9, 10, 1, 18 and 1, 9, 319.093. kg is given as 4.7. This gives you GML of 93.314.093. 0.393. Now you see what is the difference between GML and BML? 1 meter. Correct. That's why we said if kg is not given, we can use BML. You see now your BML and GML difference is just about a meter.
Yes, sir.
Yes, sir.
That's what I was trying to explain to you then. It will be only few meters, you know. But since kg is given, we'll use GML, which is the right thing to be used. So now the trim in the bilge condition will be equal to, it will come in centimeters. We'll use the unit centimeters query. What is the LCB? LCB and LCF were 76.0871. Then LCG is 50. The liver will be 3.929. Then 3.929 will be the liver BG into 100 into length of the vessel is 160 upon GML, guys, 314.393. And this will be so many centimeters by head. Why? Because LCG is greater than LCB. And this gives you the trim in the bilged condition. That is 3.929 multiplied by 100 multiplied by
2.0, sir.
okay, 160 divided by 314.393. 199.95, yeah, 2002. So 2,
So 1.99 by head.
yeah, is 2 meters by head. When you round off, it is coming to 2 meters, okay?
So TA is coming 0.946.
Yeah, so
TF is 1.04.
so split into TA. What is the TA coming?
0.946.
946. Then TF will be equal to 1.054. Now the final drafts we have forward, aft. We have the height draft after bilging, which is 7.314. 7.314. We have TF. TF is 1.054. TA is 0.946. She's down by head, so TF gets added. TA gets subtracted. Final drafts will be equal to 8638 and 8622. 2 and 7 more 3. Yeah. Have I subtracted correctly? Just confirm, please. It will be 8.368 forward and 6.368 aft. Correct, beta? 2 meters of trim.
I used this only, but my difference is coming 0.2, like 6.36.
No. What is your trim? What is your trim coming? Yeah, tell me
My
the trim.
trim is, sir, 1.998, sir.
1.99.
Okay, sir. That's correct, sir. No.
By head.
Trim of
That's okay. Because you have used 20 meters forward of it is the aft bulkhead. The length of the compartment is 15 meters. That's 15 meters here, and its aft bulkhead is 15 meters, 20 meters. So this distance is 20 meters, guys. Okay, and there is a DB tank whose height is 2 meters. Okay, that is fine. Now he is saying it is floating at a draft of 8 meters. Now, if I don't refer to Captain Dubé's book, then he says there is a watertight flag. That means if I strictly go by the language of the question, then the compartment lasts up to this place. That means only 6 meters of D minus H. This 6 meters will be the bilged portion. Yes or no? Loss of buoyancy. Correct, guys?
Correct, sir.
So if I read the question, this is what the question says. In the book, it has been solved. So there is a mismatch between the solution and the language of the question. So if I frame the question by the solution, then this word 8 meter deep should be removed. If I retain 8 meter deep, then the solution has to be as per this. New water line will be above the watertight flat in that case. But this sort of situation on a cargo ship is unlikely. Why? Because you see, you are not going to make a solid cargo lower hold twin deck watertight. Nobody makes it watertight. You just have twin deck covers. That's all. How, if you're making it watertight, then how did you put the cargo? That means you're opening all the bloody bolts, then removing the lid, then loading it, then closing it. Now, yes, it used to be there sometimes. I've seen those ships bit of Jal Mokambi, Jal Mohan in East Indias. In number one hold, below the twin deck, they had deep tanks. They had deep tanks. And since they were deep tanks to carry these edible oil and stuff, so obviously they had watertight top. Okay. Now, those tanks, those deep tanks, had the watertight lid on top. Now, if you remove that lid and you load cargo, now hypothetically you can do whatever you want to do. But it is most unlikely. I think what Captain Dubé has solved is, I think that is what he meant to say. Where he seems to have faltered is by inclusion of these 8 meter deep word here. That's my take on this question. I cannot say what should you do in the exams because that will be a tough question to ask. Uh, in personal capacity, what I can say is if this question comes exactly like this, then a safer bet may be to solve it as done in the book. Why? Because if somebody can copy a wrong question, then he'll also copy the solution from there. That's all I can say, right?
Correct.
So this is only a suggestion, but I can say nothing more than that. Because this question, we can keep commenting endlessly about the mismatch between the solution and the language. It will never end. The debate can never end like this. I hope I have made it very clear. Unfortunately, guys, I'll not be able to give the answer to this particular part. But my suggestion would be that if it happens comes in the exam, because it has already come in 2022, then my suggestion is you solve as solved in the book. Not that it is justified, but what I'm saying is, if as a paper setter I can give you a wrong question, then I will also pick up the solution from there only. So probably the risk may be slightly lesser going that way rather than ignore. And you can, what you can do in this case is that you are ignoring this depth of the compartment as 8 meters. You are taking it right up to the deck. Put a remark and do it. At least you have made your stance clear. Correct, beta?
Correct.
So because if we solve this sum using the wording given, then there won't be any cargo above the 8 meter watertight compartment.
Even if there is cargo, doesn't make a difference. So water will not come. No, even if there is cargo,
Right, the water will not come. Water will not
water,
come, sir.
water will
Right.
not come. Cargo or no cargo does not make difference above the watertight flat. Yes, correct. Then it will be fully intact. The water plane will be intact here, right?
Barabar, sir. Then your BM will be only about the whole triangle through the
Yeah,
center of
that's that,
flotation.
through the full rectangle. Yes, correct. Water
Yes,
plane will
sir.
be fully.
Yes, sir.
Yeah, correct. Correct. Yeah, you're right. So both will give you different answers. Now, which one to solve? You can toss a pen and decide, beta. Right. So that's
Understood,
why,
sir.
yeah, I didn't want to put any answers to this question because if I put answers, I'll put by taking it 8 meters deep. I can't solve it wrong and share with you that this is the correct answer. Why? But then the language has to be corrected. These words have to be removed actually. I think that's what he wants the question. And there are many such mistakes in Captain Dubey sir's book. Let me just say with all my respect towards him, there are plenty of solution mistakes. It's flooded with mistakes. So be very careful if you are referring to CL Dubey book for Bilging at least. There are many mistakes. So you can take a call on it. We can continue further on this because it has no answer from my side, honestly. I have intentionally picked it up from the paper. I know it. I knew it's a controversial question. I could have avoided it, but I wanted to take it on so that you don't later on, come back to me with doubts as to what is to be done in this case. So I've intentionally kept it here so that I can warn you upfront that there is a mistake somewhere. Okay, now we come to calculate the drafts forward and aft and the GMT after this tank is bilged by damage below the water line, below the water line. Okay. So now, which portion are you want me to calculate, GMT or the drafts? Where is it that you are having the problem?
Sir, why you are taking midship compartment as a slack tank?
It is given in the question. No, read the question.
The tank which is slack, sir. उसने बोला नहीं कि slack है ये वाला midship.
और कौन सा किसकी बात कर रहा है वो? ऊपर में किसकी बात कर रहा है? ये किसकी बात हो रही है ऊपर?
Midship तो उसने ये बीच वाला कर दिया सर ये.
So then what tank is this?
ये तो midship ही है सर.
Then read the question in continuation ना बेटा. What is the doubt in this?
नहीं सर अभी कोई doubt नहीं सर.
It is if he had to give slack, then what? Why should he give you sounding?
हाँ जी सर वही.
Why should he give you sounding? And if he does not give you sounding, then how will you know how much water was there?
Correct sir.
So how will you deal with it? Is it clear now?
Yes sir.
Okay. So now, इसमें एक you only care you need to exercise is that weight of the water inside the hold. Now, this question has slight ambiguity, but I'll take 1.015 as the density of it because he's saying it is floating in this density, right? So basically, what will you get, beta? Let me do the GMT part. Can you guys calculate initial displacement? It will be 180 into 20 into 6 into 1.015. How many tons?
21924.
21924, is it? Okay.
Yes.
Very good. What is the kg of this ship? Kg initial. Now you can from here you can get the kg. You have km. You have gm. This is gm fluid. Okay. So what you can do is first you convert gm into gm solid beta. You add FSM to it, right? FSC. So what will be FSC? FSC will be equal to 1000 divided by 21924. What is the FSC coming, beta? Can you tell me what is the FSC of the ship?
0.046.
0.046, right? So this gives you the, sorry, 0.046, my mistake. This will give you GM solid, you add it to it, it will become 0.69796. Am I right, guys? Have I added correctly? Yes or no? 0.796 is the GM solid. So therefore, the kg of the vessel will be equal to the km of 7 meters minus solid GM 0.79. If anybody has any doubts, you can interject there itself. It will be 490.
6.204.
Yeah, 6.204. So basically, the kg initial is
I have one.
6.204. Yeah, tell me.
So this FSM is created by the slack tank, or is it the full ship?
Right now, the ship is intact, man. So that is the only information you have.
But no, it says no. The tank is
No,
slack.
no. This FSM is for the full ship, right? This FSM is in the initial condition, right? This FSM is in the initial condition, correct, beta?
Okay.
See, he has given you this 6 meter draft is with the tank slack. Do you agree with me or do you have any doubt on that? Let me know. That's what I am reading out of this question.
That I agree that the tank is slack with draft 6 meters.
So then he in the slack condition is given with the FSM, right?
Okay.
Okay. Let's just to set your curiosity in place. Let's calculate I of this tank. No, the I of this tank would be 30 meter long, 20 meter wide. So it will be 30 into 20 cube by 12. How much it comes? How much
20,
it comes? Just sorry.
20,000.
It's 20,000, is it?
Yes, sir. 20,000.
The free surface moment of this tank, is it?
Yes, sir. Yes,
20,000.
Okay. And multiplied by 0.105. How much is the FSM then?
20500.
Sea water है सर.
अरे तो सी वाटर शी इज फ्लोटिंग इन वाटर ना, वही होगा ना अंदर. अच्छा सी वाटर है क्या? इज ही सेइंग सी वाटर?
Yes, sir. The tank contains seawater.
Okay. Divide by 1.025. How much it becomes then?
Multiply.
Multiply 20,000 into this. Okay.
20500.
20500. Now, this is the FSM of the slack tank. Now, see, this is where the question is a misfit, no? Because if I'm taking the draft, then 6 meters E1 keel. Now, I don't know. Then what do I take these things? Then I really don't know. Then this question is is it a MMD question?
Yes, sir. April
Yes, sir.
21.
MMD question. November 21.
Yeah, they just
November.
pick up stupid
Yes,
question.
sir. November 21. This is.
Yeah. So what I'm saying is, how can then FSM be 1,000 ton meter? FSM cannot be 1,000 ton meter, no, in the intact condition.
Just for calculation purpose, they have given, sir. We cannot go.
There is nothing like calculation purpose, na beta. Anyway, since he is given FSM, I'll be tempted to use that FSM, right?
Yes. Yes, sir.
Because if I calculate the FSM of the slack tank, it's going to come much more, right?
Sir.
So anyway, I think let's stick to the language of the question. You're right that FSM of the slack tank is much higher. Okay. Now, he cannot expect me that I take the draft 6 meters, I take the KM at so much, I take the GM so much. So this GM of 0.75 would have been calculated with this FSM of 1,000. No, that's how what I'm reading, right, beta?
Yes.
Correct? And he's saying, he's very clear. The draft of the vessel then when this tank is slack with seawater to a sounding of 8 meters, right? Right? Yes or no? So I think what we are following is correct. This is the initial displacement. This is the initial kg. Okay. What is the weight of the ballast for intermediate condition? We'll have to pump it out, right? What is the weight
Yes,
of the water?
4920.
It will weight of the
4920.
4920. So it will be for the benefit of everybody. 30 into 20 into 8 into 1.025 because you're saying seawater, right?
Yes, sir.
How many tons it becomes?
4920.
4920. What will be the kg of this weight? 4 meters. Am I right, guys? Half of the sounding.
Yes.
Okay. So now we are now in blue. I will work out the intermediate condition parameters. And this will be the solution to this question. Nothing else. We can't do anything more than that. In the intermediate condition, the displacement of the vessel will be equal to 21924 minus 4920. How many tons does it come to, beta?
17004.
004. Okay. Now, what will be the kg in the intermediate condition, guys? Kg in the intermediate condition will be the initial vertical moment, that is 21924 into kg of 6.204, which we calculated, minus 4920 into kg of 4 divided by the final displacement. Can you quickly calculate the kg, beta?
6.843.
6.843.
2
Okay. 842. Okay, never mind. Doesn't make a difference. Then we talk about the draft in the intermediate condition. It's a box-shaped vessel. Displacement is 17004 divided by 1.015. Okay, because she is floating in dock water. Divided by 180 and divided by 20. What is the draft that you're getting?
4.6.
4.654 meters. Okay. So one is he saying what will be the drafts 4 and aft. So drafts 4 and aft will be 4.654. Correct, guys?
Yes, sir.
No. She after bilging. Okay, my mistake. Okay. Now we have to bilge this ship. Okay. Now we draw the intermediate condition of the vessel. Okay, to bilging. Now density of the water outside does not matter because we are going to follow the now we are going to follow lost buoyancy method. Okay, so even the free surface in the compartment or the initial free surface will have no role to play. And that is why the fringe surface controversy will now finish off. Now she's floating at a draft of 4.654. It has an empty compartment, length 30 meters, breadth 20 meters. Now she will sink to a new draft. This will be the lost buoyancy. Okay, and there will be a lost water plane. If I draw the water plane here, there will be a loss of water plane, right? So the sinkage will be equal to, guys, lost buoyancy will be 30 into 20 into 4.654 divided by the intact water plane, 180 into 20 minus 30 into 20. What is the sinkage that is coming?
0.930.
0.9?
31.
931. Now this you add to, so your draft after bilging will be 4.65. Yeah, correct. 0.935. 5.585. So 85. Okay. So this will be the draft forward and aft. Now you agree? So answer to the draft forward and aft would be 5.585. Okay, guys?
Yes.
Done? Yes. Okay. Then he wants the GM. Now I'm sure KB will be half the draft. So KB is not an issue. KB will be
2.792.
2.792 meters. It is D1 by 2. Okay. And now we calculate the BM. BM will be geometric center of flotation will be here. So it will be ICL of the whole minus ICL of the lost. Whole would be 180 into 20 cube by 12. Lost would be 30 into 20 cube by 12 divided by volume of displacement. That is 180 into 20 into 5, 4.654. How much is the BM coming better than?
5.969.
5.969. So now you can add KB plus BM and get the KM. And from that KM, you will subtract the kg of 6.842 meters. 842 or 843, whatever you've got. What is the GM you're getting then as the answer?
1.919.
1.919. This is the answer, beta. Okay. This FSM of Y is given 1,000 and he's announced the tank to be slack. Let's not get into it because people sometimes just set paper for the sake of setting it. But these will be the answers to this question based on what is given, correct? So where was the fight? Fight was about the slackness of the tank, or what was the confusion? So let me.
Mine was FSM only because.
Yes, sir, about FSM.
Yeah, this FSM is not matching with the FSM of the tank, slack tank. Okay, for sure it's not matching, but the value is given, so why worry about it, right? Okay, beta.
Okay.
Yes.
Okay. Okay, fine. Now any questions before I go further? I'm not in a hurry at all. And I'll also keep telling you when it comes to drawing, we will be dealing with everything at the even keel condition. So that means I'll draw the water line for the trimmed condition, but I'll draw it very, very lightly. And then I'll draw the darker line, which will be even keel condition. So see, this is what my suggestion would be, that you do it like this. We have a box shaped vessel, guys, 100-meter long, 20-meter wide. Let's say this is the forward end, and this is the after end. Okay. Floating at a 5-meter forward and 7 meters aft. So basically what I'm trying to say is maybe use a light pencil, and maybe draw the actual water line like this so that you don't have confusion in your mind here that what happened to the trim. Now what it is saying is this draft is 5 meters and this draft is 7 meters. I have intentionally used a very light color because that is not what I want to be distracted by. So maybe you can use a pencil or something. And now I'll use a dark one. Now, if this vessel is, if I have to draw an even keel condition for this ship, this will be my WL at 6 meters draft. Okay, guys. So yes, it is trimmed. I've drawn that trimmed condition also, but our calculations, as I've been repeatedly saying, are done for upright even keel condition. So we create a even keel condition. Okay, she is trimmed. For that, we'll account for into the LCG. No issues at all. Okay. Now there is a midship compartment. There is a compartment whose forward bulkhead is 10 meters from the ship's forward end. So there is the same question, I think. 10 meters from here. 30 meter long, 20 meter wide, 30% permeability. 30 meters long, 20 meters wide, and permeability of 30%, 0.3. Okay. Now the first thing is, because the vessel is trimmed, LCG will not be L by 2. That is what we have to see. We know yesterday what all we have to calculate. We have to calculate D1. We have to calculate LCG final. We have to calculate LCB final. We have to calculate LCF final. And we have to calculate BML final. Once we get all these, we know how to close the question. So now, in the initial condition, I'm talking about the intact initial condition before bilging, guys. Before bilging, so now here is the initial condition. Intact condition, okay. In the intact condition, trim is 2 meters, which is 200 centimeters by stern. Okay. What else do you need in the trim formula? It is BG into 100 into length upon BML, because kg is not given. In the intact condition, water plane will be fully intact, and the center line would pass through the center of flotation. So we have to get BML, not BMT, sorry. So we draw FF. BML in the initial condition will be equal to 20 into 10 cube, 100 cube divided by 12 divided by volume of displacement. It will be basically L square by 12D if you want to cut short, okay? So length is 100, breadth is 20, draft is 6, 120 gets knocked off, 100 gets knocked off. It's L square by 12D. How much is the BML coming? Can you please calculate and give me? Hundred square upon 72. How much is it coming, guys?
138.
138.889.
889, okay, meters. Now, in the initial condition, beta, trim of 200 centimeters will be equal to BG, that means L difference, LCG difference, LCB in the initial condition, multiplied by 100, multiplied by the length of the vessel, which also is 100 incidentally here, divided by the BML 138.889. Using this, can you calculate BG in the intact condition, beta?
$2.778.
2.778. Guys, any question up to this point? If you have any question to ask. This is the difference between LCB and LCG in the intact condition. Any questions up to this point, beta? This will be the first step to get the LCG of the ship now. Even before we start getting sinkage or stuff and other things, right? Get the LCG of the ship because she is trimmed. So now if LCB is, BG is 2.778, guys. Yes? Any questions?
Sir, this BML initial will be I by V, right, sir?
Yeah, it's
So,
yeah, correct.
so
So
and that will be through the transfers, athwart ship.
why? For trim for MCTC you don't use transfers, no? You use FF, about FF, right? This is the diagram, no?
Right.
FF, yeah, this axis, right? You're right. Athwart ship axis.
Right, sir.
Yes.
Right, sir. So it will be
20
understood. Right,
BLQ.
right, sir. My
No problem.
yes, sir. Yes, sir. BLQ.
PLQ by 12 bit. PLQ by 12. Okay.
Yes.
Okay, guys. Now, for a box-shaped vessel, when it is intact, what is the LCB? Don't worry about the trim. We talk about even keel upright condition. LCB will be length by 2. Yes or no, guys?
Yes, sir.
Yes, sir.
Okay. Guys, if the ship is trimmed by stern, if the trim is trimmed by stern, is LCG less than LCB or more than LCB?
LCB more,
more
sir.
than LCB, sir.
If she is trimmed by stern, what is more? Say again.
LCB, sir, more than
LCB will be more.
LCB member more. So that means I'll have to subtract BG from LCB to get LCG. Yes or no? Correct?
Yes, sir.
Yes, sir.
So 2, 2, 2 and 47. 47.22 meters becomes the LCG of the ship in the intact condition. Yes or no? It is this LCG which is responsible for that trim of 2 meters that the vessel has. Is this step clear, beta, or anybody has any questions? This has nothing to do with bilging. It has got to do the earlier concepts, but it has to be now used here. This gets added to your work.
एक्सक्यूज मी सर
Yeah.
सर इसमें अपन ने एलसीडी 50 लिया है, इसको ट्रिम वाली कंडीशन सोच के नहीं लिया था, क्योंकि ट्रिम होगा तो ये 50 नहीं
यार
होना चाहिए।
ये तो क्वेश्चन हम हर दिन याद करते हैं ना, हर दिन यही बात करें। जब शिप बिल्ज हो गया था कल इवन कील वाला, वो भी तो ट्रिम हो गया था ना आफ्टर बिल्जिंग।
आफ्टर बिल्जिंग ठीक है सर, बिफोर बिल्जिंग अगर
नहीं,
आप
बट नहीं, उसमें आफ्टर बिल्जिंग जब तूने फाइनल बीएमएल निकाला था तो क्या लिया था? फाइनल एलसीबी क्या ली थी कल? तो वो किस बेस पर कैलकुलेट की थी? बिल्जिंग के बाद वो कैलकुलेट करके वाटर लाइन हॉरिजॉन्टल लेके किया था ना बेटा। This question we have answered many a times, that if the vessel if your MV inship has a hydrostatic draft of 5 meters, and I tell you to find out the, let us say, KML, because how do you get BML? KML minus KB? Yes or no?
जी सर।
Correct. So, a 5 meters pe, the ship can be even keel, ship can be 1 meter by stern, ship can be trimmed 2 meters by head. There can be infinite trim conditions with high draft of 5 meters. Yes or no?
हाँ जी सर।
Then if I tell you to find the BML for a MV in ship, what will you do? Every time, as long as the high draft remains 5 meters, you'll be picking up the KML for 5 meters, BML for 5, KB for 5 meters. So every time your BML, you'll get the same answer. Yes or no? Or will
Yes,
the answer keep changing if I keep shifting the weights internally and keep listing the ship or trimming the ship?
सेम रहेगा।
Same रहेगा ना? So this is what I have told so many times in the class, that when we work stability, we work it for upright even keel condition. This is what I have repeatedly been saying, beta.
okay.
Clear? No, ठीक नहीं है, तुम MV inship में question करते होगे 47.222 meters. Now we start with the same thing. Now first now it will be bilged with even keel draft line, water line. Why? Because it can be assumed as if bilging took place in the midship region and then you shifted it forward. So water will come up to that level. So we'll all work on the even keel upright parameters, right? And now this will cause the vessel to sink to a new high draft W1, L1. And the water plane in the bilged condition, the water will rise here also. The water plane in the bilged condition, I'm sure all of you would agree with me, there will be some loss of water plane in this part. Yes or no? Correct, beta?
Yes, sir.
Correct. Okay. Now LCG final will be equal to LCG initial, and it will remain 47.222 meters. Why? Because you are going to use lost buoyancy. Agreed?
Agreed.
Okay. Next, I calculate the sinkage. Sinkage will be equal to, now the lost volume will be length 30 meters of the compartment, breadth 20 meters, height, that is draft, I'll take 6 meters. I'll not make it a trapezium, okay? That is the sometimes doubt. And that's why if you see the yellow water line that I made, it has been drawn so light that it has gone out of context and out of my vision and does not create any confusion to me. Okay, then you'll say, why have you drawn the yellow one? so that it keeps reminding me that LCG is not midship in this case. LCB is not equal to LCG. Okay. Into permeability of 0.3 divided by, from this water plane down below, whole water plane 100 into 20 minus lost water plane 30 into 20 into 0.3. Can you find out how much is the sinkage, guys?
0.593.
593. This will give us the high draft of 6.593 post bilging. This will be our high draft after bilging, 6.593. Any questions up to LCG in the bilge condition and the high draft? That means draft in the final draft, high draft will be 6.593 meters. Everybody is okay with these two parameters? We have to calculate 5 of them. Yes or no?
Yes, sir.
Okay. Now we calculate the LCB and LCF will be same. So we can calculate any one of them. We can calculate any one of them that we feel like. Let's calculate LCF. So LCF final will be equal to, from this diagram down below, this diagram beta. Longitudinal moment of the whole water plane area, that is 100. If anybody does not understand the step, please interject. I'm presuming that you've done the questions yesterday and now you are in line with, you're at pace with what I'm doing. 100 into 20 is the whole water plane area, and its geometric center lengthwise will be half the length, that is L by 250. This is the longitudinal moment of the whole water plane area minus the longitudinal moment of the lost water plane area, which is 30 into 20 into 0.3. This is the lost water plane area. Its distance from the after perpendicular of the geometric center will be 75 meters into 75 divided by the intact water plane 100 into 20 minus 30 into 20 into 0.3. Can you please calculate the LCF?
Forty-seven point 527.
47.527 meters. Anybody has any questions, guys, up to LCF? Okay. Obviously, LCF will be equal to LCB final will be equal to LCF final, so that will also be 47.527. Everybody's okay up to this point, guys? See, this is how the
Yes, sir.
speed fix. Once
Yes.
you've understood, then you can just run through the thing. Now we have to get the BML in the bilged condition. Okay, let me just do it here on this part instead of messing it there. So let me first keep it, then remove it, and I'll calculate the BML here, and then take the value there straight. Achha, I have a page on the other one. Okay, I can do it. Maybe I can take that working there then, because I have to draw the BM thing again. So let me just. Okay, I can take it then. Slide show. I have kept a blank, so I can use that. Okay, now print screen. Okay, here is the working. Show from the current slide. Okay. Now let me draw the water plane here, guys, because there I've drawn a small one. We have the forward end to my right. We have the forward bulkhead of the tank, aft bulkhead of the tank, some lost water plane. Permeability is 30 meters. This is the lost water plane. L is equal to 30, B is equal to 20, capital B is also 20, capital L is 100. LCF, you have found 47.527. So here is the center of flotation. This is the athwart axis through it, FF, and this is 47.527. Now BML will be equal to IFF of the intact water plane upon volume of displacement, which will be equal to IFF of the whole water plane minus IFF of the lost water plane divided by V. Now, we draw the two axes through the geometric centers to be able to apply the theorem of parallel axis. Here will be the geometric center, 50 meters will be the geometric center of the rectangular portion. We have this axis XX through it. This is our dx1 distance that we were talking about. So this will be 39794 and 2.473 meter will be x1, and we'll have another axis here yy, and this distance will be 75 minus this one, so that will be 39794 27. Okay, okay, 20. So we get x1 and x2, guys, and now we get the values. IFF of the whole water plane will be equal to I of the whole water plane about xx, so that shall be 20 into 100 cube by 12 plus the area of the whole water plane. It is 100 into 20 into the square of the distance 2.473 square. The other two terms will be minus minus because there is a minus here. So minus the moment of inertia of the lost water plane about yy, that will be 20 breadth is 20 into 30 cube by 12 if it was completely empty, but it has permeability into 0.3 minus the lost water plane area. It is 20 into 30 into 0.3 is the lost area into square of perpendicular distance between the axis 27.473 square. That completes the numerator divided by volume of displacement 100 into 20 into 6, and this will give us the value of the VML, guys. In the way I was at
127.462.
127.462.
Okay. Now mind, we'll cancel the other one. It's okay. Okay, good. This is what we have done then. And now we are good to calculate the final trim. What you will get will be the final trim beta, which will really, because you are using final LCB, So the trim after bilging will be equal to LCB is 47.527. LCG is 47.222. So 47.527 minus 47.222 is BG multiplied by 100 multiplied by length of 100 meters divided by 127.462. It becomes so many centimeters. First, tell me by head or stern?
LCB is greater by stern.
It is by stern.
Stern, sir. LCB is more.
Okay, stern. Okay, how much is the trim beta?
23.923 cm.
23.9 centimeters.
23.
Yeah,
923.
yeah, so one decimal place. Yeah, so it will be 0.239 meters by stern. Correct, guys?
Correct.
Can you please split into TATF and apply to the height draft of 6.593. So we have the forward draft, aft draft, height draft after bilging is 6.593, 6.593. You apply TATF to it. Since she is trimmed by stern, TA will be added, TF will be subtracted, and you will have the drafts forward and aft. How much is the TA, guys?
0.114.
114 TA. Okay. And how much is the TF then?
0.125.
125.
125. Okay, so 125 is subtract. It is 8, 8, 6, 4, 4, 6.468, and add this one 7, 10, 1, 7. It's 6.468 meters forward and 6.707 meters aft will be the drafts after bilging. We need to calculate the drafts if we are carrying liquid in the bilged condition. Okay. And we'll take it through the example. What we'll do? We'll work out the intermediate condition. Which parameters are the intermediate condition? In the last case, when we were calculating GM, we emphasized upon kg. Why? Because kg would be used for GM. In case of trim, which parameter is more important instead of kg?
DM.
Yeah, but which parameter is important for trim? That is my question, beta.
LCG.
LCG. A counterpart of kg, beta. LCB is important, but there you calculated kg for intermediate condition, right? When you are calculating GM for a tank that is getting bilged, right? Yes or no? So what is there? You were talking of vertical center of gravity. Here you are talking of longitudinal location of center of gravity. Just try to strike the equivalence between the two workings. It will make your life easier. So now we will basically do what? We will empty this tank intentionally and we'll work out the new draft. Which draft? Not the forward aft. Only the high draft, because bilging will do on the even keel condition as we just did. So we don't have to. I know when if the vessel is initially even keel and you pump out something which is not amidships, it will cause the vessel to trim. That means draft forward aft will differ. But as you saw in the working that we have just completed, the trim, the draft forward and aft were not used in our working. So in this case also, I'm not going to waste my time in getting the drafts forward and aft. What I'll be more keen would be the trim. So here is the box-shaped vessel, 100-meter long, 20-meter wide, floating at an even keel draft of 6 meters. Same standard ship, guys. No difference. Okay, draft of 6 meters. It has a compartment 30-meter long, 20-meter wide. Where is the compartment? With a DB 2 meters high. The forward of the bulkhead, so same place, 10 meters from forward thing. Same question we are repeating actually. Only thing is now there is a DB here of height 2 meters. The DB is full of fuel oil of RD 0.95. Okay. Calculate the drafts forward and aft after the DB gets bilged. I hope the question is clear to everybody, guys.
Yes.
Okay. So first what we'll do, we will create an intermediate condition in which this fuel oil is intentionally pumped out with the vessel remaining intact. Imaginary condition, right? For that, we need to calculate the draft and the LCG. Initial displacement, you all know, you have calculated it earlier also. It is 12,300 tons. Correct, guys?
Yes, sir.
Now, for calculating the LCG after pumping out, I need the initial LCG. This is how you think what all you need, beta. I am thinking it aloud so that you also, you don't have to bug up, I'll need LCG. No, I need LCG after pumping out. So for that, I need initial LCG. Initial LCG will be how much, guys? 50. Why? Because it's a box shaped, even keel, so half length, right? Right, correct. What is the weight of the fuel oil, beta, or whatever, whichever oil it is? 30 into 20, yeah, into 2 into 0.95, 1140. Okay. 1140 tons. Okay. What will be the LCG of this oil, beta? That will be the geometric center would be here, and this LCG would be 75 meters, right?
Yes, sir.
Yes or no? Everybody is
Yes,
with me
sir.
on this? Okay. Now, when I discharge this, and now with this, I come to an intermediate condition, okay? What will be the displacement of the ship in the intermediate condition? Displacement of the ship in the intermediate condition will be 12,300 minus 1140. How many tons, beta?
11160, 11160.
Okay. Then we calculate the draft in the intermediate condition. It will be 11160 divided by density of seawater divided by 100 and also divided by 20. How much does the draft become? High draft?
5.444.
5.444 meters. Okay, guys. Now we calculate the LCG in the intermediate condition. I will not write any steps. We can keep calculating the way I'm showing it. That's all. LCG in the intermediate condition will be initial longitudinal moment. I'm talking to myself and I'm writing the values. Minus the longitudinal moment of the oil discharged, 1140 into 75, divided by the final displacement, 11160. How much is the LCG you'll get, beta?
47.446.
47.446 meters. Okay, now in red, I will draw the intermediate condition of the vessel. I'm sure all this being in phase 2 now, you are on top of what we are doing. That's all repetitive and basic. Now I'm drawing the ship in the intermediate condition. My ship is going to be 100 meters long, 20 meter wide. I know she will be trimmed by stern. Why? Because you're discharging something from the forward part. I know she'll be trimmed by stern. But what am I drawing? I'm drawing a horizontal line for the even keel condition, and this draft will be equal to 5.444 meters. I have this compartment here, 10 meters from forward end, length 30 meters, breadth 20 meters, and there is a dB of height 2 meters. This dB is now empty, and the LCG of this ship is 47.446 meters. Do you agree with me now in the red condition that what is drawn in red? Yes or no?
Yes, sir.
Okay, now you can build the empty compartment, and so first you find out the she will sink to a new draft again. What will be the trim? We don't know. W1, L1, and this will be my high draft of D1, right? So I think all of you can get sinkage. This will be the lost buoyancy, and the water plane will be fully intact. There will be no loss of water plane. Why? Because the bilging is taking place below the dB. Yes or no?
Yes, sir.
Correct. So the sinkage would be equal to, guys, lost buoyancy will be L B H divided by the whole water plane is intact. So 100 into 20 is 0.6 meters. So D1 will be equal to 6.044 meters. Correct? Yes or no? What has happened? See what the oil which had RD, same volume of oil, what is lost is replaced by same volume of water now. Only thing is this slight increase in distance is because of the change in the density of the tank content. When it was oil, the vessel was at 6 meters draft. With now denser liquid, she has sunk little more, and the new high draft will be 6.044 meters. Okay. Now, KB of this vessel, we'll have to calculate. LCG, we already know. Tell me, will the LCF and LCB will be same in this case? Yes or no?
No, sir.
No, sir, different.
No, sir.
Okay. Okay. What will be LCF equal to?
LC will be, sir,
50 meters, 50 meters, but whole full water plane is intact, right? Okay, very good. Let's calculate LCV. Yeah, tell me.
Sir, in this intermediate condition, we are assuming that at even keel, na, correct? Because although we know that our vessel is trimmed by stern.
In the previous question also, we knew our vessel was trimmed by stern. How did we solve it?
Yeah, that I'm saying. Sir,
So
we are.
it's a continue. No, don't make it a separate question, na, beta. It's a continuation of the same concept, right? There, the vessel was initially given to be trimmed. Here, we are saying when I pumped out, it has got trimmed. But the question is, you have a trimmed vessel. How do
Yes.
you handle a trimmed vessel, right?
Yes, yes.
So it's not a. What I'm trying to say is, why I'm trying to counter question you is that there is no shift in stance from the previous question to this one.
Okay,
So
sir.
don't make too many sub categories. Otherwise, उनको याद करते करते तुम सोचोगे पता नहीं कितना याद करना है, right?
Okay, sir.
Okay, guys, LCB will be equal to longitudinal moment of the underwater volume, which will be 100 into 20 into the draft of 6.044 into the lever of 50 meters. This is the longitudinal moment after bilging of the underwater volume. Minus the underwater longitudinal moment of underwater volume not contributing to buoyancy. That is 30 into 20 into 2 into its lever is 75, right? From after perpendicular, divided by volume of displacement 100 into 20 into 5.444. Please don't in a hurry make it 6. And give me the LCB then.
47.246.
47.246. Others can check it. 244. Okay. 246. Correct?
44, sir. 244.5. 244.
2445. 245. Okay. 245.
245, sir.
Yeah, 245. Okay, fine. That's okay. Guys, any questions up to LCB? None. Okay. Now, as far as this thing is concerned, your BML, the full water plane is intact. Center of flotation will be midships, and here would be your FF. So BML would be equal to 20 into 100 cube by 12 in the intermediate condition, guys, divided by volume of displacement. Volume of displacement will be 100 into 20 into what? Tell me.
5.44.
5.444.
153. 153.7. 153.07. 074.
074 meters. Okay. This gives us everything that we need to get the trim after bilging, when oil is completely lost and replaced by water. Okay. So the trim in the final condition will be equal to LCB difference LCG. LCB is 47.25. LCG is 47.446. So the difference between the two will be equal to 102.201. Am I right, BG? The difference between this and this, guys?
Yes, sir.
BG into 100 into length 100 divided by BML 153.074. And obviously this will be trimmed by head. Why?
Minus
Because LCG is
LCG
greater
is
than
greater.
LCB. So how much is the trim, beta?
0.131.
0.131 meters. Is it 13 centimeters, right?
Yes, sir. Yes, sir.
By head. Okay. You can split it into TA, TF. Both will be equal, half of it. Each one of them will be equal to 0.131 by 2, which is equal to 0.065. You can take it 0.65. Okay. Now you can add that and subtract. Forward draft will be equal to high draft of 6.6064 plus 0.065, and aft draft will be equal to 6.065. 044 minus 0.065. This draft obviously becomes 9, then 10, 1, 6.109 is one draft.
Forward.
And the other draft is 9, then 3, 3, 7,
5.978.
9, 7,
5.9.
8,
Yes,
979,
sir.
right?
Yes, sir. 5.97.
9 meters, okay. So the answer to the question would be drafts will be 5.979 meters and 6.109 meters. Now you will realize why yesterday I said we can start at 10 o'clock, because if we have understood what was done yesterday, then today is very minor tweaking of what you did the other day. Please review it. Let me know if there are any questions. Bilging is contained by watertight flat below the water line, then bilging does not create any free surface. Yes or no?
Correct.
Correct, guys? What was our main advantage of lost buoyancy method over the added weight method? Main concern was the free surface, right? Of course, G also, but the primary was free surface, right? Yes or no?
Yes.
Correct, beta? Now, when the free surface is not being created like in this question, because the bilging took place below in the DB region, and DB will get full. So there is no question of, so if I use added weight method, what happens? The DB has got full. There is no creation of free surface. So if you are absolutely clear about it, then in such cases, let me do this question with you by added weight method. Then what you can avoid is calculation of the intermediate condition. And then it converts into a trim problem, basically. What was the question? Question was this: 100-meter long ship, 20-meter wide, had a DB here. This DB gets bilged. What happens? The oil in this DB is out, replaced by water, and under added weight method, the oil is as if discharged and seawater is as if loaded. Yes or no, guys?
Yes, sir.
Correct?
Yes.
Okay. Now, I'm sure all of you would agree that initial displacement of the vessel is 12,300 tons. Initial LCG of the vessel is 50 meters. What was the weight of the oil, guys? 1140 tons. Yes or no?
Yes, sir.
What is the LCG of the oil?
75.
75 meters. If the same volume is now filled up by seawater, W2 seawater would be what? 30 into 20 into 2 into 1.025. How much it becomes? How much does it become, beta?
1230.
1 to
30.
30 tons. Okay. And what will be the LCG of seawater, beta? 75 meters. Correct? Correct,
Yes,
beta?
sir.
Now, if I tell you, now look at the statement now. And this vessel, box-shaped vessel, 100 meter by 20 meters, is floating at a draft of 6 meters, even keel draft of 6 meters, with DB 30 meter by 20 meter, height 2 meter, containing oil of 1140 tons. We pump out this oil and take water, which is 1230 tons. What will be the drafts forward and aft? You can all solve this question if I give you like this, yes or no? If I give you a question, a box-shaped vessel, 100-meter long, 20-meter wide, is floating at an even keel draft of 6 meters. It has a DB, which is at a the LCG of the DB is 75 meters. The DB contains 1140 tons of oil. Now 1140 tons is pumped out and 1230 is loaded, whatever, whether oil or water doesn't make a difference. That means you have additionally loaded how much? 90 tons. So now if 90 tons of additional load you put out here, or you discharge one and or load the other, whichever way you want to deal with it, and I tell you, find the drafts forward and aft, then it has nothing to do with bilging. I have not used the word bilging, yes or no? Correct, beta?
Yes.
Correct? And you should be able to do it. It's a simple trim problem then. But I don't want to take much of time. So let's solve it. What will be the final displacement of the ship? Final displacement of the ship will be 12,300 minus 1140 plus 1230. 90 tons gets added. So does it become 12,390 tons, beta? Yes or no?
Yes, sir.
Okay.
Yes.
What will be the draft of the ship in the final condition? When I'm saying draft, I mean the height draft. It will be 12,390 divided by 1.025 divided by 100 and divided by 20. How much it comes to? 6.044. Yes or no?
Yes, sir. Yes, sir.
This was the D1 you had in the previous question also, see here. Correct, guys?
Correct, sir.
So how much easier it becomes to get D1. Very good. Now we get the LCG of the vessel in the final condition. Initial longitudinal moment. Initial longitudinal moment is 12,300 into 50. Does everybody agree? Initial longitudinal moment?
Yes, sir. Yes, sir.
Minus the longitudinal moment of the oil discharged. 1140 into 75
Yes,
plus the long 90. What is the LCG of the ship, guys?
50.18, sir. 50.181.
1 second, I'll just take 50 point. Yeah, this one I don't know why
181.
it's 50.181.
Yes.
Any questions up to this point, guys? We're still using simple trim concept. Okay. Now, for a box-shaped vessel, what is the LCB equal to? 50 meters? Correct? Because we are using added weight method now. Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
The water has become part of the sea, so buoyancy is not lost. So the entire underwater volume is the volume of buoyancy now. Yes or no?
Yes, sir.
Okay. So what is my BG now in the final condition?
0.181.
0.181. Very good. Now there will be no loss of water plane either. Why? Because added weight method in any case, otherwise also it's in the DB. Okay, so full water plane will be intact and this will be the center of flotation. So what will be the BML in the bilged condition? It will be L square by 12D. Yes or no? In the final condition. Correct, beta?
Yes, sir.
Yes, sir.
Now what will be D here? Think and tell me. There is it.
6 point.
It's very good, Shabash.
6.044.
Very good. 6 point. That's what I wanted to ask. 6.044. Why? Because there's no loss of things now. No buoyancy, no water plane lost. What is the BML coming to, guys?
Sir,
13
137.877.
Okay.
0.878.
Okay, it's 878. Okay. So you see, your high draft is same as you got in the last case. Your BML values have changed, obviously. Okay. Now, what will be the trim final? Now, I'm not saying, oh, final is the Bilge condition, of course. So, final BG 0.181. Firstly, compare LCG and LCB. LCG is 50.181. Here, the G has shifted, guys, not B. So G has gone forward. In earlier case, G remained wherever it was, B shifted aft. Yes or no? Okay.
Yes.
So now G is forward, so ship will go down by head, whatever it goes down by. So BG 0.181 into 100 into the length of the vessel 100 divided by BML of 137.878. So many centimeters by head will be the trim cost. Can you find out how much it is?
13.12.
13.1.
Same as earlier?
Yes, sir.
Correct? Split into TATF, apply to 6.044, you'll get the same draftsman. Simple. Are you getting the same draft? Yes or no?
Yes, sir.
Yes.
Okay. Please see this. And don't you think it is much faster to get through this way? Rather than going to intermediate condition and then bilging it and doing all that?
Yes, sir.
But you should have clarity of concept. If you have any ambiguity that you may get confused which draft to take, what to do, what not to do, then you can forget it and stick very blindly to the method that has been discussed earlier. So here, I'm not saying you do this way. I'm just educating you. Based on your own understanding and comfort, you can decide what you want to use. Is that clear, beta? Tomorrow, if you see in the exam hall somebody doing this way, you should not feel that they know everything in a much simplified way than what you know. Now, it's only in some places you can cut short. And if you're not comfortable about, or you
हेलो।
आवाज गया क्या सर?
और चला गया।
अच्छा, सर का नेटवर्क डाउन होगा सर।